When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, communities celebrate. Awqaf South Africa, a charitable Waqf receiving organization, makes it easy to share the care. All donations are plowed into Sharia-compliant investments, while the fruits support a great variety of charitable causes. Visit the Awqaf South Africa website at awqafsa.org.za to discover how your Waqf can bless our community with the legacy of care. Awqaf South Africa, share the care. Water. As the most precious blessing from Allah, it gives and sustains life while purifying humankind and the earth. The Awqaf South Africa Water and Sanitation Waqf is dedicated to assisting schools and communities in need of water, thereby impacting on the lives of thousands, especially in rural communities, in drought-prone areas of South Africa. The need is hard to quench, as is the joy and gratitude of those who benefit from it. One borehole can cost as much as 80,000 Rand. It may sound overwhelming, but when we all pitch in, it's doable. How much will you pitch in? Awqaf South Africa, share the care. Quality education is a cornerstone of a thriving, prosperous society. However, the South African education system is under strain, necessitating the work of the Awqaf South Africa Education Waqf to help ease the pressure. Our Matric Mathematics Upgrade project alone has already impacted the lives of over 6,000 matriculants. At the Darul Arqam High School in Mitchell's Plain, the pass rate increased from 70% to a remarkable 100%. For one student in particular, it was a life-changing experience. With the very first word of the Holy Quran being revealed as Iqra, read, educating our community is an act of faith. With your help, we can transform many more lives. Awqaf South Africa, share the care.
We begin in the name of God, we glorify Him and we praise Him. May we have a program that is enriching and beneficial. Assalamu alaikum wa rahmatullahi wa barakatuh. Goeiemorgen, Sawubona, Molo, Namaste, and a hearty and good morning to one and all, to our grade 12 learners who have joined us from the different provinces, Bloemfontein, Durban, Eastern Cape, Ladysmith, Johannesburg, Limpopo, Mpumalanga, Northwest, Northern Cape. Let us know in the comments below which province you are coming to us from. Use the comment section in the Facebook and the YouTube comment section. Hit us up with a one if you are connecting via live stream during this live stream session now, and hit us up with a two if you are watching this as a post live stream session. My name is Hassanin Abdullah, and I'm the project manager of Awqaf South Africa, and I'll be the host today. So, welcome to the session. This is Maths Paper 2. Yesterday we did Maths Paper 1. It was a very interactive session, lots of questions and feedback from the participant that took part in the program. So feel free to post questions in the comment section, and as we go along, we will entertain these. Let this be a fun way of learning and an interactive one as well. SA has identified the need to upgrade the understanding and the literacy amongst grade 12 learners. We have identified that some grade 12 learners have been struggling, and this Maths Upgrade project aims to assist learners that are struggling. In this next video, this is a welcome address from Zafar Ahmed from Awqaf SA. He is also in the education sector, and he's going to talk a little bit more about Awqaf SA's Maths Upgrade program.
Good day to all of our grade 12 warriors. Indeed, you are a special group of students who have endured a global COVID pandemic, both in your grade 11 and grade 12 schooling years. And you now stand at the threshold of that all important matric exam. My name is Zafar Ahmed. I'm the Deputy CEO of Awqaf South Africa, and it's my great pleasure to welcome you to the special Maths Intervention Program that Awqaf is hosting in collaboration with our expert Maths tutor, Muhammad Kota, from an organization called Kway Maths. Now, as of 2 days ago, we had over 550 matric students that had registered for this 2-day maths seminar. Now, just a very quick word about Awqaf South Africa. We're a community-based organization. We're a charitable organization. We're an endowment organization. And we generate income so that we can assist communities in a various projects. So up to now, we've done PC labs, boreholes, cataract operations, digital marketing, and we also do a fair amount in terms of education. This particular program with Kway Maths is a program that Awqaf has conducted for a number of years now. And pre-COVID, we were actually able to go out to various communities and offer this on site. But of course, you know, with COVID, it becomes a bit difficult. But with that challenge presents us with a new opportunity. So we're able to offer this on a digital platform to you. And the added benefit of this is that you can now go back and review and re-watch this recording on YouTube or the Awqaf platform. The recordings will be there, and you can play this again and again as a point of reference. If you've missed something over the weekend, or if you want to double check something, that's an added benefit of having it done digitally. So I hope you participate fully and derive maximum benefit from this 2 days and this 2-day session that we have allocated to you. And on behalf of Awqaf South Africa, we wish you every success in your forthcoming final examinations, and indeed success for all of your future endeavors. I wish to thank you so much for participating in this program. God bless you, take care, and enjoy the rest of the session. Thank you very much.
So that was a address from Zafar Ahmed from Awqaf South Africa. So kindly please bear in mind that all of these sessions are being streamed via YouTube and Facebook. So share this link with all of your fellow peers and learners at school. And I'm going to take you through a brief video just to show you how you can access these videos. It's very important to refer back to these sessions as part of your preparation for the final paper. So we will go through this video and we'll show you how to access the Awqaf SA website. Uh, if you go into Google and you search Awqaf SA, we have the correct spelling of the Awqaf SA website. That will bring up our website, awqafsa.org.za. And when this landing page loads, there is a banner with a click through. For more information, click here. So you'll click on this banner and it will take you to the Matric Maths event page on Awqaf. And on this page, when it does load, besides the registration information, there is an archive of Maths Paper 1 as well as Maths Paper 2. So you can watch it from here, and this is an easy and convenient way to access these videos. So there we go. So we had lots of queries with regards to how to access the recordings. So feel free to share this on to whoever may benefit from this program. So let me share some more information about Mohammed Kota. Mohammed Kota is going to be the facilitator for today's session, Maths Paper 2. And Mohammed Kota got his tertiary level of education from the University of Johannesburg. He focused on maths. He is the CEO and the driving force behind the Kway Institute, and he has been the implementing service provider for Awqaf's Maths Upgrade program, and we have been conducting this program for the last 5 years. So I would like to bring on Mr. Kota to get the session on the go. Assalamu
Assalamu
alaikum,
alaikum.
Mr. Kota. How are you doing today?
Walaikum salam wa rahmatullahi wa barakatuh. Alhamdulillah from beautiful Johannesburg here. And how are the guys there in Cape Town?
Yeah, we are all well. We definitely had fun with Maths Paper 1. So we're really looking forward to Maths Paper 2. So, Mr. Kota, let's jump into it and kindly let's go through the overview for the program today.
Okay, so we're gonna kickstart now the program with analytics. I'm gonna try and bring in analytics and circle analytics together. Then we're gonna do trigonometry. We'll take a break. We'll come back. We'll crack Euclidean, probability, sequences, and series. We hope to finish off at 3:30, but if it goes till 4 o'clock, I don't know. Depending on how yesterday, some of them tapped out. I think they got a bit brain fried after 3 o'clock. So we'll try our best to try and keep it between 3 o'clock and 3:30 p.m. today. So bumper session prepared for today. I hope the learners have got their scientific calculators, they've got their stationery, they've got their energy drinks, refreshments, snacks, and stationery, exam pad, scientific calculator, and that's all that you need. And I hope they've got a good, stable internet connection, very important, so that we can transmit and we can beam to all the learners across the country. And there we go.
Okay, Mr. Kota. Take the session away and you may resume with your session.
Bismillah. There's our whiteboard. Our whiteboard is up. Just a warm welcome to all our learners. Thank you very much for all the positive comments that came in yesterday, even on my WhatsApp. All the learners from across the country that said, thank you so much. We're loving math now. We haven't seen mathematics in such a fun light before. But yeah, there's got to be humor in life. It's like this morning. Normally I wake up in the morning and I check my Facebook, I check my feeds, I check whatever came up. And the first thing that came up this morning, that woke me up this morning, Cape Townians always got that Mr. Mayers and Ricky of the Beat. So I woke up with Ricky of the Beat. It woke me up this morning. I was fresh, went for a shower, and I'm ready for action today. So yeah, once again, thanks to Cape Town, KZN, Limpopo, Mpumalanga, Johannesburg. Thank you all. Prilin Nair, Zidane, Samuddin, Namibia, mashallah, even outside the borders of South Africa. Well done. Are we going international? Okay. So Jatin Kimji, Cape Town weather, Joburg weather is quite hot today, 32 degrees, lovely, beautiful morning here. Let's get started. Let's get cracking with the program, guys. So a warm welcome to one and all. Let's get started. Right, we're starting now with analytics. Now I'm going to try and combine analytics and circle analytics, the formulas that you need to know. So put there, what are your formulas that you need to know? Number one, you need to know your distance formula. And you know your distance formula, the distance between 2 points A, B is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Very important, where do we use the distance formulas? Obviously, we use it for calculating the length of a line. We use it for proving shapes. We use it for calculating the area. And we also use it for calculating the radius of a circle. The second formula. And take these formulas down, you need to memorize them. Okay, we're starting with the gradient formula, the m of AB, and that is going to equal to y2 minus y1 over x2 minus x1. Where do we use the gradient formula? We can use it for proving shapes. We use it also, the gradient formula, for proving parallel lines. There, the gradient of the one line is equal to the gradient of the other line. For perpendicular lines, the m of line 1 times the m of line 2 is equal to minus 1. We also use it for the angle of inclination. Okay, the angle of inclination. And the angle of inclination, we're going to say tan, so that's colon, tan theta is equal to the m of the line. Then you've got your, we also use it for collinear, but they don't generally test you for collinear, but I'm just going to put it down. Collinear, if points lie in a straight line, then the m between, let's say, if we needed to find out whether A, B, and C are collinear, then the m between these two lines must equal to the m between those two lines. Number 3, the midpoint formula. The midpoint formula, x midpoint, we all know x midpoint, xm is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. Take these formulas down. I think there's somebody that just pitched up now. Kuvadia, you need me to open the gate, are you here? Okay, salam. Hamza, just go around that way there. Take the keys here. Green gate, green button. Right. Number 4. So we've got the distance formula. We've got the gradient formula. We got the midpoint formula. Then we've got the equation of a straight line. And the equation of a straight line, y is equal to mx plus c. Or if a point and the gradient is given, remember we did this yesterday, y minus y1 is equal to m into x minus x1. Then we've got, I'm going to add on here the equation of a circle. X minus x1 squared plus y minus y1 squared is equal to r squared. That is the equation of a circle, whose center is not at the origin. Meaning that you have something that looks like that. And there we go. These are your formulas for analytics. Take them all down. While you're taking them down, we'll just wait for everybody else to log in. Hassanin, everybody logging in from across the country.
That's correct. That's correct. We are all.
We are firing on all 6 cylinders. V6 math.
Yes, the weather is quite nice here in Cape Town today. Someone was asking, how's the weather in Cape Town? It's lovely. We've had some rain here today. How's the weather in Johannesburg, Mr. Kota?
Beautiful, beautiful. 30 degrees, cool, but a beautiful morning. People are out cycling. People are out jogging. People are gone out to Hartebeers. People are gone. I met somebody at the robot this morning. They stopped next to me. Hey, Mr. K, where you off to? I said, bro, where you off to? He says, I'm off to gym. I said, yeah, me too. I'm here to gym my brain. So this is called brain gym.
You're going to work the mental muscle today. We're going to prick all of our grade 12 learners today. They're going to do well. First class medals to be awarded in the final examination.
Amen, 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 amen. Okay, so we're going to try our best to do as much as we can in the little time that we have. And remember also, next weekend is the paid session. We had some inquiries yesterday. So we're also going to be doing higher order next weekend from 9 o'clock to 3 o'clock, 9 o'clock to 3 o'clock, Saturday and Sunday in this exciting program with all the higher order questions to make sure that we polish them properly. So when they finish with that paper, we hope that they finish a 3-hour paper in 2 hours. They do the same paper twice. When they walk out of the paper, they must say, we slat that paper. They don't
Mr.
think they got
Kota,
100%.
we've got a question. We've got a
Can I
question
get a
from
quick
Zegi.
explanation of the circle formula? Okay, you want the circle formula? So, you know, I'm just going to delete that. I'm just going to delete that. You know, for a normal formula, you know, for a normal circle, that is x and that is y, and that is your radius. So you know x squared, if this is at the center, if this is at the origin, you know x squared minus y squared is equal to r squared, right? The minute the circle moves, the minute the circle shifts, x and y, and that is r, now the formula changes. So this here would be the same as if this was 0 and 0. This would have been x minus 0 squared plus y minus 0 squared is equal to r squared, where 0 and 0 represents the center of your circle. So hence we come up with the same, that x minus x1, that's your formula, plus y minus y1 all squared is equal to r squared. So if this point here was 2 and that point was 3 and that radius was 5, you would now say x minus 2 squared plus y minus 3 squared is equal to 5 squared. So x minus 2 squared plus y minus 3 squared is equal to 25. And that is the equation of your circle, where 2 and 3, we change the values, we change the signs for the coordinates. Because of the negative, it changes the sign. So obviously that is the coordinates, that is your center of your circle. 2 will go there for x and 3 will go there. I hope that answers your question. I hope that answers your question. So it's x minus x1 squared plus y minus y1 squared is equal to r squared. Don't stress about this right now. I'm going to show you when I integrate it. So let's start with a model. I'm going to show you how analytics is done, and we're going to go from basic to advanced. So what I'd like you to do now is to take this diagram down. Right. So take this diagram down quickly. So let's do that. Let's do that. And let's do this. Right. This is point A. That is point B. That is point C. Let's make up a coordinate. Let's say that is 2 and 20. Let's say B's coordinates is -8 and -4. -8, -4. Let's say C's coordinates is 10 and -12. Right. A, B, C. And let's put another point D here. And we just call that point D X and Y. Now, I'm going to use this one model to try and attempt to answer every humanly possible scenario that you could be asked. Now, it's impossible within an hour to do 50 different examples. So what I'm going to do, I'm going to use one model, and I'm going to ask you, I'm going to ask you a whole host of questions based on this model. So all you have to do now is take the model and implement it in your exam. All right. So let's get started. I'm not going to put down all the questions. There might be about 10 or 12 questions. I want to save us some time. Let us go straight into the questions. Let's call this angle, let's call that angle theta. Let's call this angle here angle alpha. And let's get started with the question. So question number 1, they want the M of AC. They want the gradient. Okay, let's say the question says they want the gradient of AC. Now, boys and girls, analytics is paper 2. Analytics and circle analytics, you're going to get 2 questions. One question for 20 marks, right, broken up. And the second one also for about 15 to 20 marks. So about 35 to 40 marks is analytics. Make sure you score full marks in this. This is the place where you're going to score marks. Okay, so the gradient of AC. So we say the M of AC. And we all know the gradient formula, y2 minus y1 over x2 minus x1. Right. AC. So let's call this one x2, y2, and let's call that one x1, y1. You can call that one also x1, y1, x2, y2. No problem. You'll get the same answer. So y2 is 20 minus y1 minus 12 is plus 12 over x2 minus x1. So we're now going to get 20 plus 12, which is 32, over minus 8, which is equal to negative 4. And there we go. That is your gradient. That is your first 3 marks that you're going to get for your paper. How's it, Kuvadia? You made it today. MashaAllah. Aywallah. Okay, so that's your gradient. Take this down. Remember, you're rewriting. Please make sure you take it down correctly. You don't make any mistakes or calculation errors. That's your own study guide. You're going to be going home. You're going to be revising through these notes and making sure that you understand all the concepts. The main thing today is understanding the concept, what the topic is about, how to apply it. Now you can start working through all your past papers. Hopefully by the time you come next weekend, if you're going to be booking for next weekend's workshop, Saturday and Sunday, you'll be polished. The minute I put up a problem on the screen, you're able to do it by yourself.
Mr.
Right.
Kota, we have a question.
G, let's see, StreamYard. Will you teach us how to do? Yeah, boy, yes, of course, Tyreek. Of course. We're going to do some of them today, not all, depending time permitting. Time permitting. Right? So that's the gradient of AC. Number two. Find angle alpha. Find angle alpha. Right. So obviously, angle alpha is the angle of inclination. So we always use tan. So tan alpha is equal to the M of the line, the anti-clockwise angle, where the arrow touches. So the arrow touches which line? AC. So tan alpha is equal to the M of the line. What was the gradient that we just calculated? Negative 4. So alpha is equal to shift tan negative 4. Where's my scientific calculator there? 75,96. Give me your scientific calculator there. No, give me the two of you can share there. I think mine is in my bag, but it's fine. I'll get it out now. Right, I think you're going to get minus 75,96. Shift 10, negative 4 equals. You get minus 75,96. But be careful. This is an obtuse angle. The angle that you get here, if you ignore the negative here, what angle do you get? This is acute. How do you get an obtuse from an acute or an acute from an obtuse? You say 180 minus. So therefore, alpha is equal to 180 minus. Ignore the negative. That just shows the direction. So 180 minus 75,96. We want the obtuse angle. So plus 180, and we get 104,03 or 104,04. There we go. So we get 104, 104,04 degrees. Okay? So when you're doing it, when you're plugging this into your calculator, say shift 10 minus 4, check your answer. Our answer here is acute. If the question was acute and this is acute, you leave it. If this is obtuse and this is acute, you just say 180 minus. Are we all okay? Boys here in class, are we all okay? Excellent. So we're done with that. Let's check our eraser here. Okay, so we've got that. So we've done that. We've done that. Let's go. Let's take that out. Right, let's do question number 3. Whoa, what's going on there? Right, let's do question number 3. Right, I hope you guys took all this down. Right, now they want find angle theta for 5 marks. Now, this is a higher order question. Let's see if you guys can do it on your own. How would you find angle theta? Now, angle theta is lying in the air. It's not against your x-axis. Let's see. What would you do here? No, no, no. Right, I'm going to show you a trick. I'm going to show you a trick. Now, you know angle theta is this angle here, right? Now, you know the angle of inclination is always from your x-axis up in an anti-clockwise direction, right? So if there's no x-axis at that point, make a false x-axis at that point, which is completely parallel to that line. I'm showing you guys a trick. I'm showing you how to find angle theta or alpha if it's in the air, if it's not against your axis. So pay attention to what I'm showing you now. So now, from here, if we calculated the gradient of BC, that would give me that angle. You can call that angle angle theta 1. Then we've got the angle, this angle here, the small angle here. So that's your big angle. This is your small angle. You can call this theta 2. And obviously, so if the big angle here was 100 and the small angle was 80, then how much will this angle here be? 100 minus 80, which is how much? 20. Am I right? So we need to calculate the big angle. We need to calculate the small angle, which we calculated already, 104,04, because these two are correspondingly equal. So this angle here, the small angle is 104,04. I'm just going to put an arrow here. That small angle is 104,04. So the big angle here, so now we're going to go tan of angle theta 1 is equal to the m of which line does it touch? BC. So tan of theta 1, we didn't calculate. Let's calculate it. Y2 minus Y1. So Y2 minus Y1 over X2 minus X1. And that will give you 8 minus 4 plus 12 is 8 over minus 18. So theta 1 is equal to shift 10. Remember, we're looking for an angle, so we go shift. Shift 10 fraction 8 over minus 18. Boom. What's our answer? We get minus 23,96. Right. Now that's an acute answer. Right? If we ignore the negative, that's an acute answer. This angle is obtuse. So theta 1 is equal to 180 minus 23,96, which is equal to 156,04. 156,04. That's theta 1. That's your big angle. Theta 2, we've calculated it to be 104,04. Theta 2 is equal to 104,04. Therefore, angle theta is equal to 156,04 minus 104,04. The big angle minus your small angle. Minus 104,04. Boom. What's our answer? 51,9952 degrees. And there we go. That's how we get angle theta. So what you do, first things first, make a false x-axis at that point. Then calculate the big angle. Then calculate the small angle. Then say big angle. That's your big angle. This here is your small angle. So big angle minus small angle will equal to angle theta hanging there in the air. Agreed? Are we all good with this? Onliners, how are you doing? Are we all good? Are you understanding this? Okay. Now, like I said, I'm going to combine analytics with circle analytics. Okay. Next question. Give an equation of a line. So I'm going to dictate it for you, but I'll write it again while all of you are taking this one down. Right. Give an equation of a line parallel to AB, passing through minus 6 on the y-axis. Give an equation of a line parallel to AB, passing through negative 6 on the y-axis. So let's erase that. Let's see if you guys can do that one. I want you to do it on your own so long while I'm going to be erasing. So I want an equation of a line, parallel to AB, passing through -6, passing through -6 on the y-axis. Right, so while you're doing that one, let's see if you guys can do that. And then the next question, find the coordinates of D if ABCD is a parallelogram. Find the coordinates of D, X and Y. That's the next question. Find the coordinates of D, X and Y if ABCD is a palm, is a parallelogram. Now it's so easy, man. How can you hate it, brah? Right, so that's question there. And then the next question is, I want the coordinates of D, X, and Y if ABCD is a parallelogram. And then the next question is, find the area of triangle ABC. Find the area of triangle ABC. That's your next question, right? The area. Just remind me for that question. I'm not going to write it down now. The area of triangle ABC. And that we're going to use a little bit of trigonometry in it. A little bit of trigs. Right, so the equation of a line parallel. So let's answer the first question. The equation of a line parallel to AB passing through -6. So AB, we know for parallel lines, the two gradients are equal. So firstly, we're going to calculate the M of AB. The M of AB is Y2 minus Y1. I can call this one X1, Y1. Y2 minus Y1. So it's 20 minus -4 is 20 plus 4 over 2 plus 8. So that is 24 over 10. Am I right? So 2 goes into there 12 times, 2 goes into there 5 times. Therefore, the M of your new line is also equal to 12 over 5. Why? Because they are parallel. Therefore, the equation of the new line is going to be y minus y1 is equal to m into x minus x1. We can use this formula when we got the gradient and we got a point. And all we do, we substitute the point and the gradient, and then we bring it in the form y is equal to mx plus c. So y, I'm going to use the point 2 and 20. I'm going to use a point 2 and 20. So y minus 20 is equal to 12 over 5 into x minus 2. And we're now going to have y minus 20 is equal to 12 over 5x minus 2 times 12 is 24 over 5. So your final answer, y is equal to 12 over 5x minus 24 over 5 plus 20. Minus 24 over 5 plus 20. We're now going to get 76 over 5 plus 76 over 5. And that's your final answer. So that's step number 1. Find the gradient of AB. Step number 2, that's the gradient of the new line. Step number 3, bring it in the form y is equal to mx plus c. Yes. Oh, shucks. Oh, shucks. They picked it up. They picked it up. Excellent. We're not looking for the whole equation of that line. Yo, brah. How's that? Passing through -6 on the y. Can you see the mistakes you can make? Yo, la hawla wa la quwwata. Astaghfirullah. So, all right. Okay, let's take that out. Sorry about that. Sorry. Now, I was just checking if you were paying attention. Right, so we have to use, they say it's passing through negative, what's it? -6. So 0 and -6, 0 and -6. So y minus y1, y plus 6 is equal to 12 over 5 into x minus 0. So y is equal to, x minus 0 is x, so you got 12 over 5x plus 6 will come on the other side as -6. There we go. Or you could have said y is equal to mx plus c. 12 over 5x, and because it's passing through -6 on your y-axis, you could have just put in your -6. That's your y-intercept. All right. I know some of you were at home screaming, Mr. K, you're making a mistake, brah. Good. Mistakes are good. Mistakes are good. Right. The next question. Find the coordinates of D, X, and Y. D, X, and Y if A, B, C, D is a parallelogram. Let's see. Work on that one. I just want to erase here just so that we can see where D is. Right. So we got A, that's A, B, C, D. They tell you A, B, C, D is a parallelogram. How are we going to find the coordinates of D? I'm just going to erase this. I hope you're done with it already. I'm going to show you how it's done now. And remember, like I told you guys yesterday, if you're joining us for the first time, I will always show you the shortest, best ways to do it. Right? I will never, ever make you go through the longest process. I'm going to show you guys some tricks also today on how to complete the square, the shortcut on completing the square. Right. So all you do now, you know, because this is a parallelogram, use your midpoint. That's your easiest. You know that they share a common midpoint because that piece will equal to that piece and that piece will equal to that piece. So all you do now, first calculate the midpoint. Because it's a parallelogram, you know that the diagonals bisect. So let's find the midpoint of AC. So the midpoint of AC, is going to be x1 plus x2. So it's 2 plus 10 over 2 and 20 minus 12 over 2 and y1 plus y2 over 2. So that would give you 10 plus 2 plus 10 is 12. 12 over 2 is 6. 20 minus 12 is 8. 8 over 2 is 4. So we know that the midpoint here is 6 and 4. Now we find D, X, and Y. Right. So now we say, for the coordinates of D, we say X midpoint is equal to x1 plus x2 over 2. And we say y midpoint is equal to y1 plus y2 over 2. You make an equation. So we got x midpoint. What's x midpoint? 6 is equal to x1. Now we're working with this line here. We are now working with this line here. So 6 is equal to minus 8 plus x, that's x, over 2. And then y midpoint, 4, is equal to 4 plus y over 2. And here we go. Multiply this by 2. Just solve for x and solve for y. So I'm just going to move over here to the side because I don't have space. So 2 times 12 is 6. 6 times 2 is 12. 12 plus 8. X is equal to 20. X is equal to 20. And then 4 times 2 is 8. 8 minus 4 is 4. So y is equal to 4. We just solve for x and y. Solve for x and solve for y. And that's these coordinates. These coordinates is 20 and 4. Use your midpoint. It will be your easiest way to do it. You can make simultaneous equations. But there's always 2 ways of getting to Cape Town. You can either go the straight line and take the N1, or you can take the garden route. Don't take the garden route. Take the N1. Right, Kuvadia? Are you understanding now, Hamza? Is this all now coming into... Are you seeing it? Okay. Right. We're now going to include circles in here. What? The area. Okay, so let's find the area. The area of triangle ABC. Let's see you guys do that one on your own. That's your next question. Find the area of triangle ABC. Find the area of triangle ABC. Come on, liners. Let's see how good are you. Y midpoint is minus 4. Let me see. Why would it be minus 4? It's not minus 4. That's 10 and minus 12. That's 2 and 20. 20 minus, no, it's x1 plus x2. x1 plus x2. So what's x1 plus x2? x1 plus x2 over 2. So 2 plus 10 is 12 over 2 is 6. And then 20 minus 12 is 8. 8 over 2 is 4. We correct. No, you can't use. Victor, don't use inspection, brother. You got to show it by calculation. Remember, those diagrams on the diagrams are not drawn to scale. So Victor, Paneshe, please make sure you show all. Why 1 is minus 4? No, but we're not using AB. Yeah, but we're not using this coordinate. We're using this line and we're using that line. So we're using AC and we're using BD.
Why the y value of B is minus 4 and we use 4.
Yeah.
Yeah.
And where did I use 4? Yeah, but I'm not using this point. I'm not using this point at all. I'm using AC's coordinates. And then B, okay. Okay, so what did I say here? So Y midpoint 4 is equal to minus 4. Minus 4, there we go, minus 4. So 4 times 2 is 8. 8 plus 4 is 12. Okay. Okay. Thank you very much. There we go. Right, now I want the coordinate, I want the area of triangle ABC. Thank you, guys. Can see you guys are paying attention, eh? Solid. How do we calculate the area of triangle ABC? Trigonometry, because it's not a 90-degree triangle. So the triangle of the area of triangle ABC is going to be what? Yes, what's your area rule? Area is equal to half of a side times sine of the included angle. Am I right? So firstly, we got to calculate the distance of AC. So let's do it together. Right. So now we're going to calculate first the distance of a, let's do a B. No. We're going to calculate BC and AC. Remember, it must be the included angle. So let's calculate the distance of AC. So AC is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So AC's length is equal to the square root of, let's make sure we don't make a mistake with our signs. So 2 minus 10 squared plus y2 minus y1 minus y1 all squared. So AC is equal to the square root of minus 8 squared is 64 plus 32 squared. So let's do it all one shot on our calculator. What answer do you get there? What answer do you get there? So we got the square root of, open brackets, 2 minus 10, close brackets, squared. I'm making sure 100% so I don't mess up, into 20 plus 12, close brackets, squared. And that will give me 8 root 17. Going once, going twice, 8 root 17. That's AC. Now we're going to calculate BC. The length of BC is also the square root of x2 minus x1. Right. So x2 minus x1 all squared plus y2 minus y1 all squared. And that will equal to the square root of 18 squared plus, open brackets, minus 12 plus 4 squared. And that would give me 2 root 97. Just check. I'm sure we're right. Minus 12 plus 4 is? Minus 8 squared is 64. 2 root 97. Good. So now we're going to get the area. Area is equal to half of a side times another side times sine of the included angle. And we found that angle. What was that angle? 52 degrees. Am I right? And that would equal, so it's 2 root 97 times 8 root 17 equals, divide that by 2 equals, multiply that by sine 52 equals, I get 255,99, 256 units squared. And there we go. That is the area of triangle ABC. We're moving on good time, guys. We're moving on good time. We're now entering circle analytics. So I'm going to combine circle analytics on here.
How are we doing for time, Mr. Kota?
We're doing excellent so far. We're doing
for
excellent so far.
For the trigonometry, how are we doing for that?
We are moving excellent. We're moving on good time.
Fantastic.
We are moving on good time. Okay, onliners. Hope you guys enjoying the show so far. This is a good practice round for you for next week. Now I tell you, a circle with center B. Right. Now we're going into the little bit higher order questions. Right. We're still talking about the same diagram. So let's erase this. Yeah, you can draw a rough diagram. After I tell it to you, you can draw a rough diagram on this diagram. Okay, here goes. Right. A circle with center B goes through the midpoint of ABCD. So ABCD, the midpoint is here. That's what we're talking about. So a circle with center B, that means a circle goes through here. So, right, question number 1, they want the equation of the circle. Question number 2, they want the equation of the tangent to the circle through the midpoint. They want the equation of the tangent to the circle through the midpoint. So all you do now, let's draw a rough circle. It's with center B, right? So that means they're drawing a circle. It doesn't have to be a perfect circle. I know mine looks like a freaking potato. So you just draw it there. Let's answer the first question, right? Let's answer the first question. Right, take that down. So a circle with center B goes through the midpoint of A, B, C, D. So the circle is around B. B is the center. So it goes through the midpoint. They want the equation of the circle. Right, so we know the equation of a circle is going to be, so obviously this here becomes the radius. That becomes the radius. So obviously now we have to first calculate the length of the radius. Am I right? So the radius r squared is equal to x2 minus x1 all squared plus y2. I'm using the distance formula, minus y1 all squared. So r squared is equal to x2 minus x1, so 6 plus 8 all squared, plus y2 minus y1, 4 plus 4, 4 plus 4 all squared. So r squared is equal to 8 plus 6 is 14. 14 squared is 196 plus 4 plus 4 is 16. No, 4. Hey, 4 plus 4. Yo, how's that? My maths is bad. 4 plus 4 is 8. 8 squared is 64. So therefore, r squared is equal to 196 plus 64. I know these onliners, they're waiting for me to mess up. 260. They're waiting for me. Stuff it up, stuff it up. Go, okay, stuff it up. Right. So r squared is 260. Now the equation of your circle is going to be x minus x1 squared plus y minus y1 squared is equal to r squared, where x1, y1 is the center of your circle. So now you're going to say x plus 8 squared plus y plus 4 squared is equal to r squared. R squared is 260, so we leave it. R squared is 260. And there we go. That's the answer. Now, at this point, we don't know whether AC is a tangent. We don't know. So there could be another tangent. So this one here, the equation of a tangent, do not assume that AC is your tangent. But it looks like a tangent. But let's just see. Let's just see. The equation of the tangent to the circle through the midpoint. Onliners, are we good? How's KZN doing?
We are doing well. But Mr. Kota, just make sure that you don't go off on a tangent today. You're doing very well
No.
today.
Yeah. No, I know. You guys were going to put me into the naughty boy corner yesterday.
Yeah, I know you're behaving yourself today as long as you don't go off the tangent.
Okay, to answer that question, Zeke, to answer that question, you could have put it on this side. I just squared both sides. I squared this side, I squared that side to get r squared. It's the same formula. If you wanted to use the square root here, you could have and then squared the answer. You'd get exactly the same answer. Okay, Zeke. Let's answer the next one. Let's see if you guys can do it. Have you guys started it? Did you do it? The equation of the tangent to the circle. Right, so the first thing we do here, remember the equation of a tangent, the tangent is going to be, remember the tangent is y is equal to mx plus c. So we need m and we need a point. So let's first find out the m of our radius. So the way you do it, you can say m rad. The m of your radius is equal to y2 minus y1, y2 minus y1 over x2 minus x1. So that would give me 4 plus 4 is 8. 6 plus 8 is 14. 2 goes into there 4 times. 2 goes into there 7 times. The m of your radius is 4 over 7. Therefore, the m of your tangent is equal to minus 7 over 4. You change the sign and flip the fraction. Why? Because the tangent, remember, they're 90 degrees. They're 90 degrees because your tangent is 90 degrees to your radius. So we know this gradient times that gradient must equal to -1. So you change the sign and flip the fraction. Therefore, your equation of your tangent is now going to be y minus y1 is equal to m into x minus x1. So now we're going to go y. We have to use the midpoint. We got to use 6 and 4 because they say it goes through the midpoint. It goes through the midpoint. So y minus 4 is equal to minus 7 over 4 into x minus 6. So y minus 4, I'm just going to multiply these two out. That gives me minus 7 over 4x plus 7 sixes are 42. 42 divided by 4? 21 over 2. And now my final answer, I take the minus 4 on the other side. So y is equal to minus 7 over 4x, 21 over 2 plus 4. 29 over 2. And there we go. That is the equation of your tangent passing through your midpoint. Y is equal to mx plus c. We're going to do two more questions. Two more. I'm going to give you an equation of a circle. You need to complete the square, find the center, and find the radius. And then I'm going to ask you, another circle is drawn. Will the two circles touch? Will they have two distinct points of intersection or no points of intersection? Those are your higher order questions. And then we're done with analytics. That's it. Then we can take a 5-minute comfort break. And then we come back and then we crack trigs. Right? We just started. It's only, we started at 5 past. We 1 hour. We 55 minutes into the program. Are we all good? How's your energy level? Are you flying? Onliners, are you guys still okay? Are we all good? You took it down. Okay. Right. Let's do now. Now I'm going to give you an equation of a circle. Right. Now we know. Yeah. So in fact, I'm going to combine. I got a brilliant setup for you coming up. This lineup of questions is Kway. Is mos kwaai jong. Is mos duidelik. Is mos off the hook, Mr. Kway. Right, let's give you an off the hook question. Right, so here goes. Another circle given by the equation x squared plus y squared minus 6x plus 10y minus 5 equals 0 is drawn. Right, question number 1. Find the coordinates of the center of this circle. Find the coordinates of the center of the circle and the radius. And question number 2, will the new circle and the circle with center B and the circle with center B intersect? Show all calculations. So the first one is worth 4 marks or 3 marks. The second one is worth 5 marks. Let's see if you guys can do this. Now we need to complete the square. So I'm going to show you guys how the shortcut of completing the square. But never mind. Do it the way your teacher showed it to you in school. It's fine. You'll see the difference between yours and mine. My answer is in 1 line. Your answer will be in 6 lines. So I'm going to answer it in red, right? No, this is red. Ours is a green screen here. Right, so let's answer question number 1. Right, so firstly, you got to put it into standard form. Is that in standard form? No. So you say x squared minus 6x plus y squared plus 10y is equal to 5. Now we complete the square. So I'm going to show you a shortcut of completing the square. I'm going to get my answer in one line. So it's x minus y plus all squared is equal to. Right. How do I get this value? How do I get that value? And how do I get the value on the other side? Right. In one line. So I'm showing you guys a shortcut. I'm showing you guys a hack. So to get this value here, divide by 2. And then on that side, plus this x value squared. And what you do to x, you do to y. And divide by 2 plus y squared. So watch here. 6 divided by 2 is 3. 10 divided by 2 is 5. Is equal to 5 plus this x value here squared. 3 squared is 9. 5 squared is 25. And there we go. I completed the square. Divide by 2 plus x squared. Divide, what you do to x, you do to y. Divide by 2 plus that x value, coefficient of x squared, what you simplified. Then divide the coefficient of y by 2 plus y squared. Divide by 2 plus x squared. Divide by 2 plus y squared. I'm going to say it one last time. Divide by 2 plus x squared. Divide by 2 plus y squared on the other side. The signs will stay the same. If that's minus, that's minus. If that's positive, then that's positive. So my coordinates, my center of my circle is 3 and minus 5. R squared will equal to this whole thing. 9 plus 5 is 14. 14 plus 39. So R is equal to the square root of 39. And there we go, in one line. Okay, so we've answered the first question, guys. The coordinates of this center of the circle and the radius. Put it into standard form first. You know what standard form? X squared x, y squared y is equal to a constant. X squared x, y squared y equals a constant. That is standard form before you complete the square. Right. Now, will the new circle and the circle with center B, sorry, I meant center B, intersect. Will the new circle and the circle with center B, will they intersect? Will they just touch, or will they have no points of intersection? Who knows how to do this? Let's ask our onliners. You're in class? Nobody? What you know? Tell me what you know. Let's see. Let's see. Any of the onliners, you can type it in. I'd like to see your comments coming in here. How would you do the next one? Hasanain, any comments coming in there?
They will be coming through shortly. Our participants are very good at multitasking, entertaining the questions and giving feedback.
Let's see. Let's see if they can do. This is the last question, and then we're going for break. We're taking a quick 7-minute. We're just taking a 7-minute comfort break, and we come back and we crack. Yeah. No, we cannot say smoke break. We cannot. I didn't say that, Hasanain. I didn't say that.
Yellow
no,
card.
I didn't say that.
We're gonna mute you, Mr. Kota.
No, I'm saying we're not taking a smoke break, guys. Do not. I'm now advising you out of the best for the interest of your health. Do not smoke during the break. Go for a comfort break. Stretch arms. Breathe. Oxygen in the lungs. Oxygen.
First yellow card. First warning. We're gonna mute you today, Mr. Kota. If you're naughty, we'll put you in a naughty corner as well.
I'm not being naughty, Kasam. Today I decided I'm being good. As Kway Opi beat. Let's see here. Let's check our comments. Any comments came in there? Or is everybody, my teacher write an exam without teaching us the equations of the... Astaghfirullah, ya mullah. How could your teacher do that? The radius must be greater than 1K. Tariq, what is 1K, my brother? Must be greater than 1K. I don't know what's 1K. Zeke, you also had to do that. All right, come I'm going to give you. All right, come I show you how to do this quickly. Come I show you. You blank. Relax. Watch here. Watch here. If the sum of the radii is greater than the distance between the centers, then they will have no point of intersection. Take this down, learn it. If the sum of the radii is less than the distance between the centers, then they will have two distinct points of intersection. And if the sum of the radii, so learn this, it's rules. If the sum of the radii is equal to the distance between the radii, then they will just touch. Or another word for just touch, tangential. Tangential. Tangential means the two circles will just touch each other. So two distinct points means they'll overlap. They'll have two distinct points of intersection. Just touch would look like that. That's called tangential. And no points of intersection means that they look like that. So now you work it out. Add the two radii, calculate the distance between the centers, and tell me. So what's the sum of the radii? Okay, so let me erase this. I just need to erase the top here. All right, so let's go. What is the sum? Number one, let's do. What is the sum of your radii? Your sum of your radii is equal to. Now we got this circle here. We calculated the radius here. Né? What was the radius here? R squared was 260.
Yeah.
Root 260. Plus, what was the radius of this new circle? Root? You sure? So root 260 plus root 239. Root 260 plus root 39 equals 22,36. 22,37, right? So let's say 22, okay, let's say 22,36. Right. Now, what is the distance between your centers? Now, firstly, you got to calculate the center, the midpoint of this line. Because the circle goes like this. No. The distance between the centers. So your one center is at B minus 8 and minus 4. The other center was at what? 3 and negative 5. Now calculate the distance between there. So the distance will equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared, and that is equal to the square root of okay, let me just double check. Minus 8 minus 3 all squared plus minus 4 plus 5 all squared, and that will equal to 11,04. Let's double check. The square root of minus 8 minus 3 squared minus 8 minus 3 squared plus minus 4 plus 5 is 1 squared. It's 1. Oh man, I get 11,04. Why? Yes, 11,04. How did you get it? Minus 8 minus 3 is minus 11 squared is 121. 121 plus 1 is 122, is square root 122. Yeah, so square root 122, yeah, is 11,04. Right. So the sum of the radii is greater than the distance between the centers. So the sum of the radii is greater. So the sum of your radii is greater than the distance between the centers. Therefore, they will have no points of intersection. Because 22,36 is greater than 11,04. So they will have no points of intersection. 5 marks. You get marks for all your calculation and then for making your statement. So 4 marks for your calculation, 1 mark for stating whether they intersect or they don't intersect. Okay, it's 10 past 11 now. We take 7 minutes, guys. Take this one down. I'll leave the screen up for those of you who want to take it down. Let's take a 7-minute. Hassanin, are we good? 7 minutes. Bathroom break.
Yes. So when will we resume? At 11:15, Mr. Kota?
No, let's go at 17 minutes past.
17
It's,
minutes past.
I
Okay.
don't know. Let's synchronize our watches now. What's your time?
9 minutes past 11.
Okay, so then let's go in at
At
11:17.
past.
Let's go 11:17.
Let's try and keep it a little bit efficient today so we can have a very robust session.
Excellent. No, we're going to
11:17.
11:17. Okay, guys, hope you guys enjoyed the first session. Enjoy your bathroom break.
Thank you so much, Mr. Kota. Thank you for your participation, your questions, your interaction so far. It's been very good. Um, Kindly be advised that the session is hosted by Awqaf South Africa. Visit our website, awqafsa.org.za. Awqaf is a development organization. We are doing this jointly with the Kway Institute as well as iSkill. This is what our program is looking like. We will be doing trigonometry shortly. We're just on a comfort break for about 5 to 7 minutes. We will resume at quarter past. And this is a reminder that we are doing maths paper 2. Today we have done maths paper 1. All information can be found on the Awqaf SA's website. And please, would love to get some of your feedback um, via Instagram, Twitter, and Facebook. Send us a few photos while you're logging on during the session. Like us on Facebook, on Twitter, Instagram. Give us some of your feedback. Post a few photos. Feel free to engage with us and subscribe. So hit that like and subscribe button if you're linking on via YouTube. Subscribe so you won't miss a thing if we have future programs like this, as well as our Facebook page. We normally post some fun content, and it's our intention to have lots of programs like this. So we will be resuming at 17 minutes past 11. You may take a brief comfort break, stretch your legs, hydrate, have something to eat, and we will be resuming shortly.
Here we go, here we go, here we go. Here we go. Let's get some
Welcome back, Mr.
lovely.
Kota.
Yeah. We good, we good, we good. We got some fresh air in the lungs.
Okay, now that's good. And you say the weather is fantastic in Johannesburg. You got about
Brilliant.
30 degrees.
Yeah. Today is a perfect dry weather. People to be canoeing, people to be, yeah, we canoeing in math, brah.
Hmm.
Are we doing, what do you call that? That all terrain? Who's that
Hmm.
now? You can't be
Okay,
putting that.
so now,
No,
Mr. Kota, I
no,
wanted to have
no.
a discussion. I wanted to have a discussion, just a brief point on this, man. When I was in school, the only source of online or via TV was this Wilbur Smith,
Come on, man. Come
and
on, check my beard, man. You
he
can't
used to do
compare me.
Maths
You can't
tuition
compare
on
me, brah.
TV. Hey, but he's a legend in our time,
He's a
and
legend. He's a legend, Mr. Will Smith. Yeah.
yes, but you are the
Come,
legend of the 21st century, Mr. Kauta.
so now I need to wear a shirt. I need to have like wet armpits. No, I'm just joking. I love you, Will Smith. I love you.
He actually received some honor in his
Accolades. Yes.
from President Cyril Ramaphosa.
Yes.
So
Yes.
You know, today we have online workshops, virtual sessions, virtual classes. Are only
I got the
form
golden
of.
handshake from Katlejo Motlanti.
Okay, there we go.
So there
Fantastic.
we go.
Right, Mr. Kota, are we ready to hit the road running?
Yeah, we're ready
It's
to
on
hit the road.
time.
Is everybody online? Everybody back? Everybody had
Everyone
their
is
exams to break?
online and everyone is ready to
Alhamdulillah,
give this a go.
Alhamdulillah. Let's clear the frame. Let's clear the frame. We are done with analytics, and so please, guys, learn that. Learn these rules here, and then learn that how to complete the square, the shortcut of completing the square. Okay, so here goes. I'm clearing the frame. Shh, guys, in class, let's get started with tricks. Now, I'm just going to show you a technique. Come on, clear frame. Why is it not clearing? Let me see. Page unresponsive. Let's see. Let's go here. Jamboard. Wait. Let's see. Okay, we've got a bit of a snag here.
Okay, so what you can do, Mr. Kota, what you can do is you can.
Wait, let me.
Um,
I think I'm going to reload this page.
okay, no problem. So you
Okay,
can
but
do that at the moment.
wait, the computer is still buffering here. I'm seeing what's going on here. Why do we have that? Okay. All right, wait. I'm going to open up a new tab. I'm going to open up a brand new
No
Jamboard, right?
problem. We're looking at your face at the moment, so
Yeah.
no
Okay.
problem.
Okay.
So
Don't make Nazar, right? Google Meet. Let's see if it's opening here. Come on. Let's see. Let's open up a Jamboard here. Okay, we're opening up a new Jamboard, new meeting. I just exited and I'm reopening. I think we had a bit of an internet delay there. All good, all good, all good. We're starting with tricks, still trying to get in. And we are in. Let's see. Are we in? Are we in? Are we in, guys? Are we in? No, we're not adding other
in the
people.
meantime, guys, kindly visit the Awqaf's website. Share this link with your friends so you may view the archives of Maths Paper 1 and Maths Paper 2.
Start a new whiteboard. Okay, we're almost there, guys. We're almost there. We're opening up the Jamboard. We're saying present to meeting.
Okay, so that's what the program looks like while Mr. Kota is getting his whiteboard up. That's what our program looks like. We have done analytics, we're going on to trigonometry, and we hope to have a jam-packed session, but rest assured that we will have comfort breaks.
Okay, let's go to StreamYard. Okay, my Jamboard's open. My Jamboard's open. Let's go to share, share screen, Chrome tab, and the Jamboard. We're jamming. Okay, are we live there, bruh?
Here we go.
Are we good to go there?
Can we do like 100% perhaps?
Yep, let's go on to 100%.
There we go. Fantastic.
Okay, let's see. Right, just tell me if the picture is good. The picture and sound is good from our back end there
Yes.
in Cape Town. Cape Town,
Yes. It's
going
very
down the
good.
mountain. Let's get started. Okay, guys, we're starting off with tricks. Now, remember, before we start with this, let me give you let's give
Question.
you a roadmap. Let's give you a roadmap on how you're going to score marks for paper 2. Right. I know paper 2 is a nightmare for most of you. Now, remember something. Your data handling, that's easy. That's mean, median, mode, standard deviation, Ogive curve, variance, one standard deviation away from the mean. That's easy stuff. That's 20 marks. Then we've got analytics. That's 30 marks. So we got 20 marks there. We got 30 marks there. That already gives you 50 marks there. Then with your trigs and your trig graphs is another 50 marks. So that would give you another 100 marks. That would give you in total 100. And now 100 out of 150 is 66.666, which is about 67% already. Now I know you guys are crying because now we do Euclidean. Now Euclidean is 50 marks. But relax. 30 marks out of the 50 is grade 11 work. Only 20 marks is grade 12. Right. Now I know the grade 12 one kicks you guys. When you're calculating with the similarity and proportionality, your grade 11, proving theorems, calculating the radii, using Pythagoras, that's all 30 marks. So 30 plus 100 is 130. In fact, even if you scored full marks here and you left that out, you can still get 85 to 90% for your paper. So don't stress about this one too much. Come on, why am I not connecting?
We got a question here, Mr. Kauta.
Okay, wait. You know what? We're having a bit of a technical issue here.
What
Some of
seems to
them
be
are
the
making
issue?
up. A lot of them I'm taking from past papers, and a lot of them I'm making up because of our experience, and we know what's coming out. Okay, so let me just go through this. Am I connected again?
Yes, you are connected. We can
Jamboard,
see you.
everything is all okay?
We can.
Okay,
Perfect.
excellent. All right. Now, so that's your roadmap. So let's start here, guys. Let's start. What do you need to know in trigonometry? Number one, you need to know your reduction. That is your special angles. Number two, so that the question will say simplify. Right. Then you've got to know your identities. And that will say prove. And that you've got to prove left-hand side equal to right-hand side. Then you've got solve for x or general solution. That's your next topic. I'm going to be taking out past paper questions from here. So most of the questions here are going to be, unless I need to explain to you a concept, then I make up a scenario, I show you the concept. But then when we do the application, I then take out from past papers that are sitting here next to me. Right. So reduction, identities, general solution. Then we've got what we call substitution. So this looks like this. If sine 21 equals P, find blah, blah, blah in terms of P. Then you got your non-90 degree triangles. And that's your area rule, your sine rule, and your cos rule. And then you've got trig graphs. So I'm going to show you how to do each one of them. Okay, so these are your 6 topics for trigonometry. These are your 6 topics for trigs. By now, I hope you know your rules of reduction. I'm going to quickly go through your rules of reduction. I have to go through it because I know many of you don't know it, and that's why you suffer in trigonometry. So let's go through all the rules first. I'm going to go through your rules of reduction, your rules of identities, and your general solution, but we'll go through it as we go topic for topic. So let's first start. I hope you've taken these 6 topics. This is what will give you your 50 marks in your exam. So let's start with reduction rules. So let's open up. Can I delete the screen, or can I open up a new screen? Have you taken it all down? Okay, so there we go. Let's go down. Let's go to 100% again. Right. So now put down your rules of reduction. So now if I give you an angle like, let's say sine 180, or let's say sine 240 degrees. Now, when you reduce 240 to a special angle, to an acute angle, you know you have to use your 30, 45, or 60. So now we're going to say sine. Do I say 180 plus 60 or 270 minus 30? 180 plus 60. Try and use, now from your Cartesian plane, you know that if an angle lies, that's 90, that's 180, that's 270, that's 360. If an angle lies here, it could be 90 plus or 180 minus. If an angle lies in this quadrant, 180 plus or 270 minus. If it lies in this quadrant, it's 270 plus or 360 minus. And if it lies here, it's either 0 plus, right, 360 plus or 90 minus. What you want to do is you want to use the 180. So you want to use the horizontal line. Why do we want to use it? Because the name stays. We don't want to change the name. 90 and 270, the name changes. To the co-function. So sine will change to cosine and cosine will change to sine. So sine 180, 240 is there, 240 is there. So we use 180 plus because we want to keep the name. So sine, that would be sine 60. The 180 will fall away. 180 plus is in this quadrant, your third quadrant. And we know that sine in this quadrant, sine, the original in that quadrant is negative. And that will become minus root 3 over 2. So there we go. So even if I gave you cos 135, that will become cos. Will I say 180 minus or 90 plus? 180 minus. Now 180 minus how much will give me 135? 45. And that will equal to, we keep the name, cos 45. 180 minus is in your second quadrant. Cos in your second quadrant is negative. That's your special angle. Minus 2 over root 2 or minus root 2 over 2. That's your special angle. Okay, so the first law of reduction is using our Cartesian plane. Okay, so I hope you've taken that down. The second law of reduction, very, very, very important, guys, is your negative angles. Negative angles. So this is rule number 2. Your negative angles. So sine of a negative angle is equal to minus sine of that angle. Tan of a negative angle, to remove the brackets, becomes minus tan of that angle. But cos of a negative angle is positive cos of that angle. Cos changes to positive. A negative angle does not exist in the world of cos. Why? Because a negative angle is 0 minus, is there. And we know cos is positive there and cos is also positive there. So cos of a negative angle, that negative just falls away, it becomes positive. So learn this. We're still going to get to double angle and compound angles just now. So that's your negative angles. Now we're going to do the next law, which is your anti-clockwise angle. Right, your third law. So the first one was the Cartesian plane. The second one, the second law of reduction was your negative angles. So sine and tan of a negative angle is minus sine or minus tan. Cos of a negative angle is positive. Right, now we're doing the anti-clockwise angle. So put the heading anti-clockwise. Now anti-clockwise would look like this. Sine x minus 180. Now, how do we, normally we have 180 minus, now x plus 180 is not anti-clockwise because if you swap it around, watch here, if I told you sine x plus 180, that's not anti-clockwise. That's not anti-clockwise because that's 180 plus x, you can swap it around. But sine x minus 180, that's anti-clockwise. So what you do, watch here, put down your pens. Where is sine? So you know this is going to be sine x because sine 180, the name will stay, yes or no? Right. Now we need to determine whether it's positive or negative. And how do we determine whether it's positive or negative? Look at the original sine is in this quadrant. That's sine. Right. We're going to move 180 degrees anti-clockwise because it's x minus 180. So we're going to go from here to here is 90. From there to there is 180. Now what is sine in this quadrant? It lands here. This is 180. From there to there is 90. From there to there is 180. Now, what is sine in this quadrant? Negative. Very good. That will change to negative sine x. So even if I told you cos x minus 270, let's do that one. Cos 270 will change to sine x. Now, where is cos? Cos is in this quadrant. Hamza, how many degrees anti-clockwise must I move? 270. So we go from here, from cos, we go here, 90, 180, 270. So cos now lands in this quadrant. What is cos in this quadrant? Negative. That's how you do your anti-clockwise angle. Please learn. Absolutely crucial. We got two more sets of laws here to do. Very quick. So the first one was your Cartesian plane. Second one was your negative angles. And you'll find it on the DVDs. Those of you who got my videos, the DVD kit, you'll find this also on the kit. The next set of laws is, so we got the anti-clockwise angle. You got your square angles. So watch this. Your square angles. Right. Anything squared is always positive. So even if I told you sine squared 270 minus x. Now sine 270 will change to cos squared x. Do I need to check whether it's positive or negative? No. Why? Anything squared is always positive. This was your fourth set of rules. Your last set of rules is an angle greater than 360. Example, cos 480. Now you know you don't get a 480 or 720 or 540 degree angle, because the circle has only got 360 degrees. So for an angle greater than 360, you always minus 360 from the angle. So this would be cos 480 minus 360 is 120. Now you reduce this to cos. We're not going to say 90 plus. Why? Because we don't want to change the name. We want to keep the name. So we're going to say 180 minus 60. Cos 180, name stays. Cos 60, the quadrant falls away. 180 minus is in your second quadrant. Cos in your second quadrant is negative. Now minus cos 60 is minus half. There we go. Those are your rules of reduction. Okay, so let's start firing off. Let's give you some questions now from past papers. I think it was, let's see, Triggs 161. Let's go to page 161. And let's give you some past paper questions. Now, before we do that, let's do our compound and angle, double angle rules. Please remember, memorize these rules. Memorize these rules. You don't have time in the exam. Are we all good there, Hasanain? Sound and picture, are we all good?
Yes, we are. We're getting some
Excellent.
good feedback from the participants
Excellent.
that we are
Mashallah.
doing fine.
Mashallah. Now we're doing the compound and double angle. Now this is the grade 12. Now the compound and double angle is integrated in all your questions, right? Now what does a compound angle look like? Compound angle and double angle. So compound would be sine A plus B. Two angles being added or subtracted. Now I'm going to teach you how to remember it. Just remember, for sine, Hamza, you can never distribute here. You can never say sine A plus sine B. It will never give you the same answer. So that's why we have a rule. So to break this up, this becomes sine cos, cos sine. Just remember, for sine of a compound angle, sine cos, cos sine. Sine cos, cos sine. And the S from sine will help you to remember that the sine stays the same. S for sine, S for the sine stays. Right, Hamza? So we put a plus here. Then we put AB, AB. So sine cos, sine of a compound angle, sine cos, cos sine, the sine stays the same. Right? There's a little rhyme for you. Sine of a compound angle, sine cos, cos sine, the sine stays the same. So if it was sine A minus B, it would be sine cos, cos sine. There would be a minus AB, AB. But cos of a compound angle, watch here, don't write. Cos of a compound angle, it's cos, cos, sine, sine. And the sign changes. C for cos, C for change. So sine of a compound angle, sine cos, cos sine, the sine stays the same. Cos of a compound angle, cos cos, sine sine, the sine changes. So I'm going to teach you the compound angle, the double angle, 3 times an angle, 4 times an angle, half an angle. So I'm going to show you all the different scenarios, how to play around with them in your exam. Sine, let's do it again. Let's say it again. Sine of a compound angle, sine cos, cos sine, the sine stays the same. Cos of a compound angle, cos cos, sine sine, sine changes. Excellent. Mashallah. Eh wallah. The double angle would look like this. Sine 2a, sine 2 times an angle. Now sine 2a can only be broken up in one way, the k way. 2 sine a, cos a. Sine 2a, sine 2 times an angle. So sine 2 times 15 is 2 sine 15 cos 15. So sine 2a can only be broken up in one way. But cos 2a can be broken up in 3 ways. By now you should know cos squared a minus sine squared a. You can't say plus because that's equal to 1. So cos squared a minus sine squared a. If you only want it, or if you only want it in terms of cos, we say 2 cos squared a minus 1. Or if we want it only in terms of sine, 1 minus 2 sine squared a. So sine of a compound angle, sine cos, cos sine, the sine stays the same. Cos of a compound angle, cos cos, sine sine, sine changes. Sine 2a can only be broken up in one way. 2 sine a, bit of a rhyme to it. So it will help you to remember. 2 sine a, cos a. But cos 2a can be broken up in 3 ways. Cos squared a minus sine squared a, not plus. Cos squared a minus sine squared a, 2 cos squared a minus 1, or 1 minus 2 sine squared a. So when I'm doing, when we applying it to the exam scenarios, don't ask me where I got the rules from, because I don't want to come back to the rules and teach you the rules. Okay, are we all good? Thumbs up. Right, let's start. Let's start. Now they might ask you to simplify to a single trig ratio, right? I hope you all took this down. Did you guys take it down? Good. Let's start. Right, they tell you to simplify. Now watch this. They tell you to simplify. I'm taking it out of a past paper. Sine 3a cos a minus cos 3a sine a. Now please guys, when you see something like this and it's worth 4 marks, do not go and break the 3a up into a plus 2a. Do not. You already seeing here, Hamza, look here, you're already seeing sine cos cos sine. 3a, 3a. So what rule is this? The sine compound angle. So it's sine 3a minus a. You don't change the sign. The sign stays the same. So this is equal to sine 2a. That's it. That's it.
Question.
Yes. Yes, these rules are there, but I train you to remember these rules, so it makes it so much easier. You don't have time in the exam for every question to keep on looking. And sometimes what they do is that they rearrange the formula on your formula sheet to try and confuse you. You don't have time to go and rearrange it on the exam. So memorize these rules. So it makes your life so much easier while you're working with them. And not all the rules are given. Not all the rules. Yeah, your sine and double angle, compound angle, and your double angle rules are given. But those reduction rules are not given. That you got to know. So you might as well learn all your rules one time. So it makes it so much easier to work in your exam. Let's go back to our Jamboard. Okay, now what's the difference between this and what's the difference between the next one? Right. Show that. This is also from a past paper. Show that sine 3a is equal to 3 sine a minus 4 sine cubed a.
Question.
5. Okay. All right. Your mark allocation is for each of your steps. Right? For your first step, they'll give you 2 marks. For your second step, they'll give you 2 marks for that, 2 marks for your final answer. I'll show you here also. So this one here is worth 5 marks. Right, now how do we do this one? On the left-hand side, now this becomes an identity. So now we start with the sine 3a. Now watch here. Watch here. This is 3 times an angle. Now we need to convert everything to sine. My right-hand side is all in terms of sine. So watch here. So sine 3a, we always break it up. If it's a 3, we break it up into compound. So that becomes sine a plus 2a. 1a plus 2a is equal to 3a. I'm putting a tick there. I hope you all understand. Guys, I'm only doing this problem once. So put down your pens. If you don't understand it, put down your pens and watch how I unpack it. I'm not going to re-explain because it's long. We don't have enough time. So watch. 3a is a plus 2a. Now that's your compound angle. So that becomes sine cos sine a 2a. Follow me. Follow. So I broke that up and the sign stays the same. Right. Now we got sine. Remember my right hand side is in terms of sine. So here's sine a, Hamza. Now my cos 2a in terms of sine is 1 minus 2 sine squared a plus cos a, there's nothing I can do with it now, times sine 2a can only be broken up in one way, 2 sine a cos a. Agreed? So I put a tick there. I've broken up the cos and I've broken up my double angles here. Now I remove the brackets. So sine a times 1 is what? Sine a. Minus 1 times 2 is 2. Sine times sine squared is what? Sine cubed a. Plus, Hamza, this is all one term. So this is 2 sine a. Cos times cos is what? Cos squared a. So I got sine, I got sine, I got sine. Where's my problem? Cos squared. Now cos squared according to grade 11 in terms of sine is 1 minus sine squared. So now let's write it again. Sine a minus 2 sine cubed a plus 2 sine a. And cos squared is 1 minus sine squared a. Yes or no? Right. Now let's break this up. So let's remove the bracket. Sine a minus 2 sine cubed a plus 2 sine a times 1 is 2 sine a. Positive times negative is a negative. 2 times 1 is 2. Sine times sine squared is what? Sine cubed a. Now collect your like terms. 1 sine a plus another 2 sine a is what? 3 sine a. There's your final answer. 3 sine a minus 2 sine cubed minus another 2 sine cubed is minus 4 sine cubed a, which is equal to your right hand side. Therefore, your left hand side is equal to your right hand side. And there we go. That's how we break it up. Bob's your auntie, if they're Kardashian.
Is that the flow joke of the day today, Mr.
That's
K?
your
You're on
flow
fire.
joke. Bob's your auntie if your uncle is Kyle Jenner.
Don't go there, please.
Okay, all right, okay. This is social media. Maaf,
Please.
super maaf, wallah maaf.
That naughty boy corner is going to close in on you, Mr. K.
Well, I went home yesterday. I told my wife I got two yellow cards yesterday. She was laughing. She said you should have got a bloody red card.
Okay, I think we need to have a session with your wife, a consultation session there. So we'll sort you out for good.
She'll say, take him away, please. Get him some psychiatric help. I swear, I go and sit at restaurants when I'm bored and I'm sitting there and I'm waiting for the food. I ask them for a pen and a paper and I start doing general solution.
Okay, fantastic.
It's not right. It's not right. I promise you, it's not right.
You're obsessed with mathematics. We understand that, Mr. K. So there is some method to your madness.
Yeah.
Brilliant with what you do.
No, inshallah, Allah must. But it's like I told you yesterday, it can become troublesome at times. It troubles me. Because if you're sitting in a room and you start counting the bricks, you know you're not normal, bruh. And you're trying to calculate. No, astaghfirullah. God
We got
save
a
us.
question here from Nasiha. Mr. K, will we be
Yep.
doing proofs as well?
Yes. No. What proofs of what? Which proofs?
Okay, so Nasiha, in the comments below, kindly just clarify
Yeah,
your question.
just clarify which proofs are you talking about? Okay, now watch this question. Watch this question. Here's a higher order question for you. Clear frame? Right. Prove that in any triangle ABC, that sine A is equal to sine B cos C plus sine cos B sine C for 4 marks. Prove that in any triangle ABC that sine A is equal to sine B cos C plus cos B sine C. That's a higher order question. Let's see. Let's see how many of you guys can crack this one. How do you know what to do next? Is it trial and error or what? I'm not with you. No, you see, you got to prep on these type of questions so that when you see it in the exam, you know exactly how to unpack it. So to Mbalenhle Glamini, to answer your question, when you see sine 3 times an angle, to prove it to equal to sine on the other side, you got to unpack it the way I showed you. It's not trial and error. There you got to break it up into a plus 2a, like we did it. So sine 3a or sine 3x will equal to sine x plus 2x. And then you expand it into compound angle to make sure that you get it into sine.
Nasiha has clarified her initial
Such as
question.
the probability proofs or the center is at times the circumference theorems or 10-chord theorem. No, I'm not going to be doing proofs. I'm only doing application. Your proofs are your bookwork. That's all in your book. Just memorize. I'll tell you which ones to learn for your exams. But that's all in your textbook that you can just memorize them. Right? I'm only doing application. Right. Now, I know many of you are suffering in this one. How many of you got the answer to this one? How many of you onliners have got the answer to this one? Let's hear. Okay, let me show you how it's done. So all you do, you draw a triangle. That's A, that's B, that's C. Now we know in this triangle, sum of angles of a triangle is equal to 180. Am I right, Kuvaria? So we know that angle A is equal to 180 minus B plus C, sum of angles of a triangle. So in your answer in your exam, you're going to say angle A is equal to 180 minus B plus C, sum of angles of a triangle. Sum of angles of a triangle equal to 180 degrees. So they want sine A. So watch what we do. We attach a sine, we attach a sine. So we say, therefore, sine A, oopsie, wait, let me just delete that. Let's go back to our pen. And we say, therefore, sine A is equal to sine 180 minus B plus C. Now we know according to our rules of reduction, 180 minus the, so sine A, watch this, sine A is equal to sine 180, that will stay the same, that will fall away, is equal to sine B plus C. 180 minus sine is positive. Now we know our compound angle for this, Hamza. So sine A is equal to sine B plus C is going to be sine cos sine BC plus BC. And there we go. 1, 2, 3, 4 marks. All right. So let's pick you up again. I'm going to do some more examples, some more simplification problems for you, just to get you used to with it. No, just do it step by step. So say angle A is equal to 180 minus B plus C. So attach a sign, attach a sign. Okay, let's do the next one. The next one is quite simple. I'm going to take you up into more difficult ones. We're going to go up in levels of difficulty. Right. Find cos 105 without the use of a calculator. So in our answer, we need to use our special angle. So cos 105 is going to equal to cos, which two special angles will give me 105? My quadrants won't. It's 90 plus 25. 25 is not a special angle. And you can't say 180 minus 75 because 75 is not a special angle. So that means we're going to use 60 plus 45. Now that's our cos compound angle. So that's going to be cos, cos, sine, sine. Do you see now how it remembers? So I think somebody asked me earlier, don't we get this in our formula sheet? But you see, if you know it by memory, it makes it so easy. So it becomes cos, cos, sine, sine. And cos of a compound angle, does the sign stay or change? C for cos, C for change. So cos 60, it's also good to memorize these. So I'm not even using a calculator. Cos 60 is a half. Cos 45 is root 2 over 2. Minus sine 60 is root 3 over 2. And sine 45 is root 2 over 2. So that would be 1 times root 2 is root 2 over 4 minus root 6 over 4. Your final answer here is root 2 minus root 6 all over 4. So they can also make it like an identity and say, show that cos 105 is equal to root 2 minus root 6 all over 4. You'll just work out left-hand side, which is equal to right-hand side. So this could be a simplification problem, or it could be a identity. Okay.
Question.
Yes.
Priyanka's got a question.
Okay, Priyanka, I'm taking out the questions from a whole variety of sources. You can work through all your past papers. You can even work through your textbooks. You can work through your classroom mathematics. You can work through your platinum textbook. You can work through your mind action series. I'm also working through, I've got a past paper book compilation here, right? It's called Mathematics Grade 12, The Solution. You can work through your answer series. You can also go on to NSC past papers you can Google NSC past papers, and you can find out all your Eastern Cape, Northern Cape, Western Cape, Gauteng, Polokwane, Northwest papers. Eastern Cape and Northwest papers are also a little bit more challenging. You can even go through your Sakai website. You can even go to IEB, collect all those papers. There are millions and millions. I need to show you how it's done, because once we understand how it's done, you can then apply it to any past paper scenario. What I'm even going to do, I've even got your trial paper here, right? Your prelim paper. So I've got maths paper 1, maths paper 2 here. We'll even go through some of these questions here. I've got all these sets of papers here. So there's so much of information out on the internet, but if you don't know how to tackle it, you're going to be lost all the time. I'm going to give you another question that I've got here, right? What if it's 4 times an angle? I'm going to show you 4 times an angle, and I'm going to show you half an angle. So let's do that. Watch this. If I say, show that cos 4x is equal to 1 minus 8 sine squared x plus 8 sine to the power 4x. That's also a past paper question for 6 marks. Now I showed you 3 times an angle. 3 times an angle, you made it a compound. Whenever you see 4 times an angle, you make it double. So we start on our left-hand side. So you want to try it on your own. Give it a go. Break cos 4x up into a double angle. So that would be cos 2 times 2x. So we made it a double angle. Now, which of your cos double angle formulas have got only sine? Look at your right-hand side. Your right-hand side has only got sine. So to answer, I think it was Glamini who asked earlier, what do we do? Do we do it just by trial and error? No, we're not doing it by trial and error. There's an art to it. There's a style to it. So the style of this one is if it's cos 4 times an angle, you break it up into double. And you look at your right-hand side. Your right-hand side is in terms of sine. So which of your cos double angle formulas have only got sine in it? 1 minus 2 sine squared. What's your reference angle? 2x. This is your cos double angle formula in terms of sine. This is your cos double angle formula in terms of ITO, in terms of sine. Now what happens here? Many of you get lost here in the exam. What do? Are you squaring this or you squaring that? You're squaring sine 2x. So that becomes 1 minus 2. Sine 2x will be, sine squared 2x is sine 2x squared. You bring that square up to the top. So now 1 minus 2. Sine 2x can only be broken up in one way. 2 sine x cos x squared. Now that becomes 1 minus 2. 2 squared is 4. Sine squared x cos squared x. You shower the power. You know what shower the power? Like Zuma. You just shower. You just shower it. You shower the power. So that is 1 minus 2 times 4 is 8. Sine squared x cos squared x. Now we got a problem with cos. We need to convert it to sine. So I get 1 minus 8 sine squared x. Cos squared x is 1 minus sine squared x. No, it's one term. It's one term here. Now, because it's two separate terms, we distribute. 1 minus 8 times 1 is minus 8 sine squared x. Negative times negative is a positive. 8 times 1 is 8. Sine squared times sine squared is sine to the power 4x. And there we go. Ting, 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 ting. Bob's your auntie, which is equal to your right-hand side. Game over.
Bob's your uncle.
Bob's your auntie, bro.
Mr. Kauta,
Yeah,
are we going to see a glimpse of Hamza? Because we're just hearing of Hamza, but we don't get to see Hamza.
yeah. You want to see Hamza he doesn't want to take a photo. He say he look like Bin Laden. So he say
No.
Hamza don't like music also, bruh. He was even fighting with Awqaf. He say why Awqaf is playing music in the beginning.
Now we
Hamza,
don't have music today. We don't have music
Hamza
today.
just arrived on Friday from Iraq, from Afghanistan.
Okay.
The plane.
Okay, time out. We're going a little bit too far. Let me just
I'm going
answer
on
this
a tangent.
question quickly from
Gee, bye.
Brandon. Will I be able to access this video at a later stage? Yes, certainly.
Yes.
All that you need to do is log on to the Awqaf SA's website, and that's going to be very easy for you. That's the address. Once you're on that website's address, awqafsa.org.za, on the landing page, you go through to the Matric Maths online workshop page, and then you will have access to Maths Paper 1 and Maths Paper 2. I hope that answers your question. And also you can search on Awqaf SA on YouTube, and it will bring up the videos for the 2 session. I hope that helps you there, and let us know if you have been able to access that. Thank you, Ailey, also for flagging that question. Thank you so much.
Okay, excellent. We're still doing some more. I'm going to do one quick reduction. I'm now taking out of KZN 2019. G. Your special angles. Yeah, okay. Good question here. Is there a way to remember your special angles? Yes, there is. No, forget about all of that. Come and show you what to remember. Right. Just remember sine 60 is equal to square root 3 over 2. So if sine 60 is square root 3 over 2, that means your sine 30 must equal to a half. So if you remembered sine 60 is root 3 over 2, then sine 30 is your half. Then cos 60 is equal to a half. and then cos 30 is equal to your sine 60, which is your root 3 over 2. Then your sine 45, cos 45, sine 45 and cos 45, you know both of them is root 2 over 2. Tan 45, you know, is 1. Right, I'm just doing this. Somebody asked here in class here, is there a way to remember it? So sine 60 is root 3 over 2, so sine 30 is a half. So cos 60 can't be sine 60. So cos 60 is your half. Cos 30 is your root 3 over 2. Sine 45, cos 45 is your root 2 over 2. Tan 45 is a half. Tan 30. It would be nice if it was just root 3, but it's actually not. It's root 3 over 3. So that means your tan 60 is equal to root 3. And there we go. There's your special angles. So you don't need to remember it. Otherwise, you just use your calculator, man. They're not going to know in the exam as long as you give your answer in third form. You don't put decimal, so you can cheat legally. Right, legal cheating. Okay. Let's take another one here from a past paper where they give you your, so I'm just deleting, this is KZN 2019's final paper. So I'm just going to write it here on the side. Let's see if you guys can do this one quickly on your own. Tan 180 minus theta times sine 90 plus theta all over cos 300 and then sine theta minus 360. So while you guys are taking that one down, do this one, yeah? In fact, what we'll do, I'll do a Limpopo 2019 after this. So the next one is sine 163. Let's see if you guys can do this one. Sine 163 over cos 73 minus sine 90 plus theta. This one is worth 7 marks. The next one. Tan squared. Oh, God, I don't have space. Tan squared theta minus 360. Theta minus 360 all over cos 180 minus theta. Cos 180 minus theta. So this one is worth 7 marks. Correct these two. Both from past papers. The first one, KZN 2019. The second one, Limpopo 2019.
Question.
I'm going to check now.
I see you've mastered the eraser. You've got a broader stroke there. Well done, Mr. Kauta. 10 out of
No,
10
yeah,
for you.
because we expanded the page. I think we brought it up to 100. I think we were working on 50%.
Fantastic. There we go. Fantastic. Well done to me and you.
Excellent. Thank you, Asane. The calculator rationalizes the denominator. Can we still use the rationalized number? Yes, you can, as long as you don't use decimals. As long as you don't use decimals. So let's do the first one. I'm doing the first one here. So tan 180 will remain tan theta. 180 minus is in my second quadrant. 180 minus is in my second quadrant. Tan is negative there. Multiplied by sine 90, the name changes to cos theta. 90 plus is in my second quadrant. You look at the original, you don't look at the change. Many of you look at the changed one. Don't. Look at the original. So sine 90 name changes to cos. 90 plus is in my second quadrant. Sine in my second quadrant is negative. All over. Cos 300 will become cos 360 minus 60 times, that's your anti-clockwise angle. So let's see, theta minus 360. So sine 360, your name will stay sine theta. Sine is in this quadrant. We're going 360 degrees anti-clockwise. So from here, we're going 360 right round. We end up back there. What is sine in this quadrant? Positive. Now negative times the negative is a positive. So our two negatives cancel out. Tan theta is sine theta over cos times cos theta over 1 divided by Cos 360 minus 60 is cos 60. And what's cos 60? Half times sine theta. Now, cos theta, sine theta, sine theta. You're left with 1 divided by a half. So times 2 times 2, your answer is 2. That's your first one. That's the answer to your first one. Oh, come on. Hasanain, we still there?
Yes, we are.
Okay. Now, sometimes it just tells me, you know, my heart skips a beat every time it says reconnecting. My goodness.
Yeah, I think lots of the folks are probably on Netflix. You know, they binge watching. Maybe it's affecting the up and down speeds, but we're all
Yes,
good.
yes. We all good. We all good. Are we all good? Yeah. Zaim, we okay? Umaid, we okay? Kuvadia, we okay? Yasin, we all right? Okay, guys in studio, we all right. There's still so much
We
that we
want
need
to
to
see
do.
Hamza. We want to see Hamza.
You want to see Hamza? Okay, I'm gonna take a photo of the class. I'll send it to you. I'll take a photo of Hamza and I'll send it to you, right? Then you can.
No. I've got a
Guys,
photo of the class, but I need to get Hamza's permission if we can flight it. If he's not happy with it, then
no,
we
he says
can't
no. He says
violate
please.
his.
He says please no, please no.
Okay, so there we go. Okay, so Hamza, we hear you, but we won't flight a photo of you.
Right, so we good to go there. Right, let's look at the next one. I hope you guys are you guys done with the next one. The next one looks a bit. I've never done it before. I'm not even working with the memo here. So let's see. Let's see what the next one looks like. How do we unpack the next one? Hey, erase now. Don't trouble me. Whew, okay, here goes. Bismillah. Sine 163. Let's see what we have there. So we've got sine 180 minus 17. Okay, wait, let me get 17 doesn't look too good. Yeah, we could. We could. Or we could change. Okay. So I'm just using cos 180 minus 17, right? Or you could, like Kuvadia said, he used 90 plus 73. So, okay, let's try 90 plus 73. Both of them would have given you the same answer, right? So this is sine 90 plus 73. Now remember earlier, now you're going to tell me, yeah, but Mr. K, you said no, don't. I said avoid using it. I don't say don't ever use it. In this case, it's good to use it because then we can get a cos 73 in it. Over cos 73. Minus sine 90 will change to cos theta. 90 plus is in my second quadrant, sine is positive, so that will stay. Times tan squared 360 will remain tan squared theta. Anything squared is always positive. Remember, according to our rule of reduction, anything squared is always positive. Divided by cos 180, the name will stay cos theta. 180 minus is in my second quadrant. Cos in my second quadrant is negative. Negative times this negative will make it a positive. Okay, so now sine 90. Sine 90 will change to cos 73. 90 plus is in my second quadrant. Sine is positive there. Over cos 73. Plus, now the cos and the cos will cancel out. Right? And then we just left here with tan squared theta. So this is equal to cos 73 divided by cos 73 is 1 plus tan squared theta. And that's your final answer. You can't do anything further with that. See? Yeah, it's fine. But that's your final answer. 1 plus tan squared. You can't do anything with the tan squared theta. Okay. Now let's do trig substitution. If sine 21 equals, so I'm going to show you guys something now. Okay, watch here. 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 What if the question said, find sine 22,5 without the use of a calculator for 7 marks? Now this is half an angle. So sine 22,5, we know 22,5 is related to which angle? 45. So I showed you 2 times an angle. I showed you 3 times an angle. I showed you 4 times an angle. I'm now going to show you now half an angle. So whenever you have half an angle, so learn this. We start off with cos of the double angle. We start off with cos 45. I'll show you why. Cos 45, we know cos 45 is root 2 over 2. That's your start point. Don't ask why. I'm about to explain to you why. Now cos 45 is cos 2 times your double angle, 22,5 is equal to root 2 over 2. Now your cos double angle, which one has got a sine in it? 1 minus 2 sine squared 22,5 is equal to root 2 over 2. So this is your cos double angle, and we broke it up into sine. Now all we do is we make sine 22,5 the subject of your formula. So now we're going to go minus 2 sine squared 22,5 is equal to root 2 over 2, root 2 over 2 minus 1. So let's go to our calculator with, let's say, root 2 over 2 minus 1. As long as, so you're now going to have minus 2 plus root 2 over 2. Divide by minus 2, divide by minus 2. So let's divide that by minus 2. So now I get sine squared 22,5 is equal to minus 2 plus root 2 all over 4. And now I want sine, so we find the square root, we find the square root. Therefore, your final answer, therefore sine 22,5 is equal to the square root of root 2 minus 2 over the square root of 4 is 2. And that is your final answer. Kway.
Question.
Yes.
Smith has a question for us.
2x. You double the angle, the cos 2x. What happened to the first 2 in the bracket? That falls away in your double angle formula. Cos 2 times 2x is 2 cos squared x minus 1, or 1 minus 2 sine squared x, according to your rule. According to your rule, cos 2 times 2x. It's like this here. What happened to this 2? Cos 2 times 22,5. According to your cos double angle rule, this is 1 minus 2 sine squared. That's your double angle rule. So sine 22. So this is half an angle. This is what you do with half an angle. You start off with cos of the double angle. Then you break it up. So cos 45 is 2 times 22,5, which is root 2 over 2. And your cos double angle will then be 1 minus 2 sine squared 22,5. And you just make 22,5 the subject of your formula. We're going to do something similar in the next question. Watch here. From a past paper. From a past paper. Onliners, are you enjoying it? The initial question was, if sine 22, 5 is equal, or simplify sine 22 comma 5 without the use of a calculator. Sorry. Simplifies, right? Simplify. Here's your original question. Your original question is simplify sine 22 comma 5 without the use of a calculator. Or they can say show that sine 22 comma 5 is equal to the square root of root 2 minus 2 over 2. Okay. Let's delete this. Now watch here. If sine 22 is equal to P, here's the question. Find. Question number 1. Find cos 22, tan 22, sine 44, sine 82, sine 11 without the use of a calculator. So the first question is worth 2 marks, 2 marks, 3 marks, 3 marks, 5 marks. 2 and 2 is 4 and 3 is 7 and 3 is 10. 15 marks on this question. So in your answer, now whenever you see a scenario like this where you're going to draw a triangle, come I show you a quick acronym. You use what I call scrap. You scrap it. The first S is standard form and SOHCAHTOA. C stands for Cartesian plane. R, look for a restriction. A is just for and. A is for and. And P is for Pythag. So this is the mental process that you use. So you scrap it. Whenever you need to draw a triangle or without the use of a calculator, and you need to construct your Cartesian plane, you use scrap. You scrap it. What do? You scrap it. So standard form, this is not in standard form. What's standard form? Trig function of an angle is equal to a fraction. So you must have a fraction there, P over 1. SOHCAHTOA, opposite over hypotenuse. Sine is opposite over hypotenuse. Cartesian plane, let's draw the Cartesian plane. Restriction, is any restrictions? No. No restriction is given. So we draw it in our first quadrant. That's 22. And Pythagoras. So P over 1. So that's P over 1. Opposite over hypotenuse. So we use Pythagoras to finish it. So let's find x. So 1 squared is equal to x squared plus p squared. So 1 minus p squared is equal to x squared. So x is equal to plus or minus the square root of 1 minus p squared, plus or minus. So we know this is on the positive side, so that's the square root of 1 minus p squared. Are you all okay with that? So we scrap it. Standard form, SOHCAHTOA, Cartesian plane, restriction, and Pythagoras. Right. So now let's start answering the questions. Now you use this. Now let's start answering the question. So we just use SOHCAHTOA. Cos 22 is equal to, for cos, according to SOHCAHTOA, adjacent over hypotenuse. Adjacent over hypotenuse. So adjacent over hypotenuse, so it's a square root of 1 minus p squared over 1, which is equal to the square root of 1 minus p squared. Number 2, tan 22. And tan 22 is opposite over adjacent. Opposite over adjacent. So your answer would be p over the square root of 1 minus p squared. Question number 3, sine 44. What is the relationship between 44 and the angle that they gave you? Double. Good. So this is equal to sine 2 times 22. And your double angle for sine is 2 sine 22 cos 22, which is equal to 2. They want your answer in terms of P, right? They want all your answers in terms of P. So 2, what is sine 22? P. What's cos 22? The square root of 1 minus P squared. Now do the last two. Now I'm going to leave you to do so you got the first three. The first three are easy. Let's do number 4 and number 5. Let's see how well you do with number 4 and number 5. And here's it, Pumalanga 2019. If sine 28 equals A, find cos 28, find sine 64, find sine 4. It's exactly the same. So when you're working through past papers, if you can do this one model, you'll be able to do all the other models that look like this. Do number 4 and 5. Let's see how good are you. If you can get number 4 and 5 right, you're a boss. You're a haunt. Away on. Then you're a haunt. Woof, woof.
Mr. Kota, you should have been a Dave Chappelle comedian kind of guys, you know? You would have done
Right. I
quite
think
well there.
we need to do a 2-day stand-up comedy only with maths, bro. We integrate maths with
Mm.
everything.
Learning the fun way.
Your Papa's a smoke show. You know, Alfred Adrian, he's a boss. He's my, Papa's a smoke show. Mama's a smoke show.
We can call you Wilbur Smith.
You.
Okay, I won't flash that on screen anymore. Clearly, Wilbur Smith and Mr. K, they don't fit in the same live stream, eh?
Sine 82. Sine 82. What's the relationship? Where do you get a 22 in here? 60 plus 22. Good. Did you guys check that? I vase you. Are you guys vase? Are we making you vase here? So sine 60 plus 22. Who's a smoke show? So that becomes sine cos. Cos sine 60 22. 60 22 plus. You're the one learner put on there yesterday. You're Mr. K. I never laughed so much in a maths class in my life. Kway, you got to have fun. You got to have fun doing maths. If you're not, your maths will mess you up. You got to look for the humor in it. And maths is filled with humor. You know you can, Hasanin, you can swear someone in maths.
Is it?
See there. So sine 60.
Okay, I can see where you're going. Let us just leave it at that. This
Okay,
is
let's
a
leave it there.
PG-13
You can
show.
reply a person also. You can say, okay, anyway. Sine 60 is root 3 over 2. Cos 60. La hawla wala quwwata. You never saw that. That was never on the show. Right. Anyway. So sine 60, I know some people are cracking up there. It's all right. It's all right.
No,
I know
but
they're going to
Mr.
give me a
K,
red card.
Mr.
Yes.
Kota, you must bear in mind that this is a permanent archive, so whatever we're saying here, it comes with responsibility, and everything goes viral out into social media. So let
Mini
us
me.
not find ourselves
You
wanting.
guys want Austin Powers? Mini me. My Fage. My Fage.
Okay, moving on.
Okay.
Moving on.
Moving on, sine 60 root 3 over 2 cos 22 is root 1 minus p squared. Austin Powers. Groovy, baby, groovy. So that's cos 60 is a half and sine 22 is p. So you just leave it like that. I want to see you guys dala the last one. Whoever dalad the last one is a boss. Whoever dalad the last one is a haunt. Yeah, so you start with cos of the... Are we vibing here, bruh? Are we vibing? Okay, okay. The Owens are getting vase here. Hulle raak vase. Kykie, my broer, al die dinge moet sy los van die week se geld en hy blik se kos en as ek kyk is, dan kry ek mooie dinge om te idle om 'n hoek om 'n pyp te rook.
PG-13, eh? PG-13, please.
Die ice cream, die sagga, die wyn en die dagga, dit slaat jou lekker dronk en dit sit jou in die tronk. So, julle moet raak wys. Okay. Let's go. Awe. Sign 11. So sign 11, we're going to start off with... Now we know that sign 11, okay, wait, Blom. Take a chill pill here, Owens. Right, so are we going to go? So we know that sine 22, let's start off with the cos double angle, right? Let's start off with cos 22. Remember I said for half an angle, you start off with cos. So let's start off with cos 22. Cos 22 is equal to, what was cos 22? It was square root 1 minus p squared, am I right? Yes or no?
Yeah.
So this is cos of 2 times 11 is equal to the square root of 1 minus p squared. Agreed? So now cos of your double angle in terms of sine, because they want sine 11, is 1 minus 2 sine squared 11 is equal to the square root of 1 minus p squared. Now make sine 11 the subject of your formula. So minus 2 sine squared 11 is equal to root 1 minus p squared minus 1. Then we divide it by minus 2. So sine squared 11 is equal to all of this. So it's 1 minus p squared minus 1 divided by negative 2. Oops. So our final answer is going to equal to sine 11 is equal to, so it's the square root. So it's the square root of, remember we're dividing it by a negative here. So that would be 1 minus the square root of 1 minus p squared over root 2. So it's a square root of this whole thing. So it's a square root of everything. And there we go. That's what sine 11 is equal to in terms of p. Yeah, it's fine. If you left it as negative 1, they won't penalize you for it. But in maths, you don't want to leave the negative, a negative in the denominator. You want to try and make your denominator positive.
But if you left it like that,
Yeah, it's fine. It's fine. Okay, it's 12:30 on the dot. I think everybody is now hungry. People want to now go and cup a chow, cup a diet, go and eat a Gatsby. Right. Everybody's list for that Gatsby now. That Gatsby is going to wipe down. Okay, Asanine, where are we at now? Let's look at our program. We finish here. You know what? I've allowed some time. We're going to continue with tricks. I'm going to do the general solution, and we're going to do some 2D and 3D tricks after break. And then we'll kick into Euclidean. So it's now 12:30. Let's go till 1 o'clock. Or you guys want to go till 1:15? 1:15. So guys who want to make salah. So let's go till 1:15. Let's go till 1:15. Let's go till 1:15. Let the guys go and make salah and let the guys go and eat a lekker diet. Okay, time to line. Have a lekker break. Make salah. Make dua. Assalamu alaikum. I see you guys at 1:15 on the dot. Onliners, enjoy your break and tell everybody what a great show this is. Okay, love you guys lots. See you guys now. Assalamu alaikum. Tot ziens. Goeiedag. Good.
Okay, so now we will be taking a comfort break. Mr. K and some of the learners that's in studio at the Johannesburg office. Going to be taking a comfort break, so this is a time for you to stretch your legs, go outside, get some nourishment, get something to eat, and come back, and we will resume at 1:15 promptly. Thank you so much. Don't forget to log on to the Awqaf SA's website, awqafsa.org.za /Matric Maths. That's the website that you need to log on to in order to find the archives of the past paper. So I'm going to take you through that demo quickly. This is something that we flighted yesterday. So don't be confused with that Maths paper 1. So you go to Google, you put in Awqaf SA. In the search engine, it'll bring up Awqaf SA's website, awqafsa.org.za. You click on that hyperlink, it'll take you onto the homepage. And once you're on to the homepage, there is a click through banner. For more information, click here. Once you click on that click through banner, it'll take you to the Matric Maths online workshop page. And on this page, it's very important. It's going to assist you to view the archives of yesterday's paper, where we dealt with Maths paper 1, as well as Maths paper 2, you will find on this page. So that's it. That's a very good information for you to access that. So I'm off. I will be taking a comfort break, and I will be resuming with you at 1:15. Thank you so much.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, communities celebrate. Awqaf South Africa, a charitable Waqf receiving organization, makes it easy to share the care. All donations are plowed into Sharia-compliant investments, while the fruits support a great variety of charitable causes. Visit the Awqaf South Africa website at awqafsa.org.za to discover how your Waqf can bless our community with the legacy of care. Awqaf South Africa, share the care. Every single orphan child in South Africa should have the opportunity to enjoy a carefree childhood. But with over 2 million children in need of orphan care, the need is greater than the available resources. The Quran reminds us of two fundamental rights of orphan children: the right to support and the right to be treated with dignity. The Quran furthermore sees taking care of orphans as an act of worship. By supporting the Awqaf South Africa Yatim Waqf, you will help us support a number of children's homes with the upgrading of infrastructure, their healthcare, education, clothing, and overall well-being. Help us share the care and give an orphaned child a chance at a happy childhood and a bright future. Water, as the most precious blessing from Allah, it gives and sustains life while purifying humankind and the earth. The Awqaf South Africa Water and Sanitation Waqf is dedicated to assisting schools and communities in need of water, thereby impacting on the lives of thousands, especially in rural communities, in drought-prone areas of South Africa. The need is hard to quench, as is the joy and gratitude of those who benefit from it. One borehole can cost as much as 80,000 Rand. It may sound overwhelming, but when we all pitch in, it's doable. How much will you pitch in? Awqaf South Africa, share the care.
Hello.
Let's fire off. Right, are the guys ready to go live? Are they ready to go live? Hey, Brew, are you ready to go live, hey?
Just give me 3 minutes, Mr. Kauta. 3 minutes.
Okay, okay.
Next week,
Huh?
next week, me, Auckland Park.
Auckland Park, boardroom. I can have two pools.
Where can I go to Auckland?
There's a dustbin there.
Hold it. Come, because I use the arms there. Use the shoe. Why you never take it? It's not. I think that everything was laid out. I said, please eat more. I said, I can't eat more. It's not burning, it's things inside. Don't burn. Ciao. I told you, go to father. As soon as I phone you, people go to hey, your car also got cup with the hey. There's a three, use that three. Behind you. Let's use the box. No, use that three.
Use a box, use a box, use a tray, use whatever you can.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, communities celebrate. Awqaf South Africa, a charitable Waqf receiving organization, makes it easy to share the care. All donations are plowed into Sharia compliant investments, while the fruits support a great variety of charitable causes. Visit the Awqaf South Africa website at awqafsa.org.za to discover how your Waqf can bless our community with the legacy of care. Awqaf South Africa, share the care. Quality education is a cornerstone of a thriving, prosperous society. However, the South African education system is under strain, necessitating the work of the Awqaf South Africa Education Waqf to help ease the pressure. Our Matric Mathematics Upgrade project alone has already impacted the lives of over 6,000 matriculants. At the Darul Arqam High School in Mitchell's Plain, the pass rate increased from 70% to a remarkable 100%. For one student in particular, it was a life-changing experience. With the very first word of the Holy Quran being revealed as Iqra, read, educating our community is an act of faith. With your help, we can transform many more lives. Awqaf South Africa, share the care.
And we are back. I hope that you are all refreshed from your break. You got some vitamin D, got time to stretch, to hydrate, to just give that mind of yours a little bit of a time out. And we are back with Mr. Kota. Mr. Kota, you are now unmuted and you can take the show away. So let us just go back to our program and just let our participants know where we are at the moment. So, what are we dealing with now, Mr. Kota?
Okay, are we back, Brew? All
Yes,
right,
we land.
we back. Right. Okay. I hope you guys had a lekker break. We covered trigs this morning. We did the whole of analytics and circle analytics this morning. We're continuing with trigs. We took a break, so don't worry about circle analytics after the break. That has been done already. And if you missed anything this morning and you just joined the show, or if there's anything that you guys would like to do, please log on to the Awqaf website. Don't go to YouTube. Don't go to Facebook. Go straight to the Awqaf website. You'll see the link. You'll see the match show. You'll see the link to YouTube. You click on the link and boom, the whole program. You can review, replay the program over and over and over again. Go straight to AWQAF Awqaf SA.org.za and click on the link. Is that correct? There we go. Awqaf South Africa, www.awqafsa.org.za. For those of you who just joined, I'm Mr. K, Mr. Kota from the Kway Institute here in Johannesburg. We're beaming here from Emerencha, Greenside. And we're talking to all the learners across the country. Hassanin gave us some stats. He says that we had over 1,300 views last night, which is excellent. So that means 1,300 learners across South Africa has been tuned into the program. And if they missed the program yesterday, they reviewed and replayed the program last night, got into groups, worked with the program. And inshallah, we hope that it meets its desired impact. And obviously, for those of you who have just joined, we are having a next week program. This week is a free program. Next weekend is a paid program. You can contact us, contact Awqaf, Brother Hassanin or myself. My number is 081-706-3986. It's 350 Rand. People have been asking me how much is it for next weekend. It's 350 per day. For the whole day. We start at 9 a.m. We finish off at 3 p.m. We're doing paper 1 on Saturday, paper 2 on Sunday. All the advanced questions, as I was explaining to Hassanin just during the intermission, that mathematics is an ocean. There's so many different types of scenarios. We can try our best to try and do as much as we can to make sure that you understand it. However, we need extended time, and that extended time will come in with extended exposure and engagement with you guys. So like I said, next weekend, Saturday and Sunday is a paid workshop. If you'd like to book, you can contact me. You can WhatsApp me also directly, 081-706-3986. It's going to be epic. It's going to be epic. It's our last workshop before the final exam. And inshallah, Hassanin, what we might even do is even do another workshop for paper 2 on that Saturday. You know, they write the Monday and the Friday and the Monday. We might do a workshop on that Saturday. We'll still negotiate with Awqaf whether we're going to do a broadcast session. We might even do it as a broadcast session on that Saturday just for paper 2. So guys, don't fear. We're here to assist you. We're here to look after you. We're here to mentor you. We're here to help you right through until your final exams. And inshallah, you guys all going to get your distinctions. So without any further ado, let's get started. Back to the program. Let me open up my Jamboard. Hassanin, are we good to go? Is the runway clear?
We are good. We are all cylinders firing. Yes.
Clear for takeoff. Right, guys, we're starting now with general solution. Now, I know many of you guys don't know what general solution is. You guys suffer with this. There are 2 types of general solution. Either the question will say, find the general solution, or it will say, solve for X. Right? If it asks for the general solution, you only give your answer in general solution. If it's solve for X, you look at your restriction. You look at your restrictions also. Right? Now, just to explain to you for general solution, just a quick recap for all of you. I know, remember, some of you say, Mr. K, go into the heavy stuff. I can't go into the heavy stuff. We don't know. I don't know at what level some of the learners are at. Some of you are below 20s. Some of you are in your 30s. Some of you are in your 40s. And some of you are in your 80s and 90s. So just work with us with the program so that we can accommodate everybody and the entire spectrum of grade 12 learners across the country. So welcome, SA. Welcome to the Kway Awqaf Maths Show. I'm your host and presenter, Mr. K, from the Kway Institute here in Johannesburg. Love you lots. Let's get started. Okay, so general solution for sine. Whenever you're solving for X or giving the general solution, you're going to get your answer, and you attach your general solution, it's an attachment. So you say plus k times 360, where k is an element of integers. Z is integers. Why? Because one complete sine cycle will make its appearance every 360 degrees. So for cos, we say plus minus. Don't ask why, just do it. You always put plus minus in front of your angle. Also plus k times 360, where k is an element of integers. To explain to you why plus minus, because cos is positive there and cos is positive there. Plus minus. 0 plus, 0 minus. And it also makes its appearance, you know, your cos graph makes its appearance. That's what a complete cos cycle will look like. It also makes its appearance every 360 degrees. So for sine and cos, it's your answer plus k times 360, where k is an element of integers. And for tan, it's your angle or your answer plus k times 180, where k is an element of integers. Why? Because your complete tan graph makes its appearance. You know, the tan graph has got asymptotes. You remember yesterday where I got the yellow card for, right? 90 and 270, right? The asymptotes, the lines which your graph won't touch, and it makes its appearance every 180 degrees. So you know the tan graph would look like that: 0 up, 180 up, 180 down. One complete tan graph makes its appearance every 180 degrees and not every 360. So just a quick recap. General solution: sine k times 360, cos put plus minus in front of there, plus k times 360, tan, your answer plus k times 180. Why? Because it's got asymptotes. It's got your asymptotes. Right? I'll write it out in full. I won't write the abbreviation of it. Right? It's got asymptotes from 90 to 270. Right? People ask, you make so much jokes, don't you worry what people have to say? How do you sleep at night thinking that people don't like you? I sleep very nice. I sleep without clothes so that people can kiss my asymptote. Okay, let's
Mr.
so let's get
Kauta,
started.
that's a
Okay,
red card. I'm gonna
now.
put you on mute. You're on mute.
Astaghfirullah, astaghfirullah. Let's
This
get
is your
started.
last
General
chance, Mr.
solution.
Kauta.
No,
I've
they
just
didn't hear that.
unmuted you
They
now.
heard that. It went past. It flew over the head like Mach 3 speed, F-35 fighter jet. All right, let's clear that.
I'm gonna be out of a job here, Mr. Kauta.
Me also, man. All right, let's start here. Give the general solution. Now, right, here the question says here, give the general solution, right? So give the general solution. Right. So now they tell you the question in the exam. If they tell you, let's say root 5 sine theta minus 2 is equal to 0. Right? And x is an element of 0 to 360 degrees. Give the 360 degrees. Give the general solution. All right. So what we do now, right, I'm going to give you another abbreviation, another acronym. Remember, I told you guys for trig substitution, you use scrap, standard form, SOHCAHTOA, Cartesian plane, restriction, and Pythagoras. Right. For general solution, you use SSGR. Now, that is the mental process. That's how you unpack it. I've summarized your notes. The first S, so just SSG, that's a G. Right. Stupid students get rabies. That's, I don't know, make up something. Make up something dumb that you can remember that will be hilarious for you when you're writing your exam, right? Don't go and write SSGR in the exam. I told you, your teachers will write WTH, right? So SSGR, the first S is to put it into standard form, right? The second S is for you to use your shift key on your calculator to look for your angle. G is to attach your general solution. And then R, look at your restriction. So let's put it into standard form. It's not in standard form. So we're going to go sine x is equal to 2 over root 5. So x is equal to, so that's your first S. There we go. Your second S, let's use the shift key on your calculator. Shift sine 2 over root 5. And you get 63,43. So you get x is equal to 63,43. All right. That's your shift key. Now attach your general. What's your general solution for sine? Plus k times 360, where k is an element of integers. Now for sine, we got to give 2. Where is sine positive? From 0 to 360. Quadrant 1, quadrant 2. So that's your answer for quadrant number 1. For quadrant number 2, you say or. You must give both solutions. Or x is equal to, if an angle lies in quadrant number 2, what is it? 180 minus. So 180 minus 63,43 plus k times 360, where k is an element of integers. So x is equal to 180 minus 63,43 is 116,56. 116,56 plus k times 3. That's your general solution, your two general solutions. They didn't say solve for x. They just said give your general solution. If they told you solve for x, you'll put in your integers. What are your integers? 0, 1, 2, minus 1, minus 2. You put it for k. Say they made it from 360 to plus 360. Then only do you put in your integers and give all your solutions that fall within your restriction. And you do the same here. 0, 1, 2, minus 1, minus 2. And see whichever of your solutions fall within your restriction. Okay? Or your domain. That's your domain. Your domain is from 0 to 360 or minus 360 to plus 360. So that's your first general. So SSGR is how we unpack it. I'm going to show you some different variations. So guys, I am sure you're definitely going to get a general solution in your exam. Or solve for x you have to get. You're going to see an identity, a double and compound angle identity. You're going to see a trig substitution. You're going to see a reduction. You're going to see a general solution. This is what makes up your trig component in your paper. So that was the first one. Let's look at the second one. What if I told you 5 sine, now watch here, clear the screen. So if I told you root 5 sine x plus 15 minus 2 is equal to 0, and x is an element of 0 to 360. Okay, question, answer. Okay, how's our onliners? Are they all good? Onliners, are you guys enjoying the show? Right. Cape Town, KZN, Maritzburg, Namibia, Joburg, Limpopo, Polokwane. How are you guys? Tariq, oh my God. Haibo, where are you from? Bushle, where are you
This
from, my
was
brother?
this was comments from your previous profanity, Mr. Kauta. Your last strike.
On my last strike, where I got striked out.
Yes. Yeah, no, definitely. We muted you. We muted you for a few seconds there.
Yeah. They mustn't carry on like they angels, man. Yes, like.
Mr.
Right.
K.
Yo, Mr. K, jy's mos onbeskof. Jy's mos niks lekker. Yo, hou mee, bro. Hoe praat jy dan? Some even for a flavor, madam, some tomatoes for a party. Right. So sine x plus 15 is equal to, so we take this 2 over root 5. Root 5. Okay, guys. It's like 2 over root 5. Hey, bro. You want me to talk like the guys from Durbanville? Hey. Hey, Marchana. What do we do now? Hey, we now got sine x plus 15 is equal to 2 over root 5. So now we do the general solution. Eh? So we do use the shift key. Eh? We use the shift key. Eh? So shift sine. So our reference angle is 2 over root 5. So we had 63,43, hey, bro, plus k times 360, where k is an element of. Don't worry. Don't mind me, please. I didn't take my meds this morning. I forgot it on the table deliberately.
Mr. K,
right.
That is Lankif, bro.
That's Lankif, eh? It's like Lankif, eh? It's like Lankif, Machana. Let's do this. I'm from Benoni. I'm like from the Alberton, Germiston side, eh? No, please let me just talk normal. Okay, wait, let me calm down. Right, I think the dopamine has kicked in. My ADD has kicked in. Okay, right. La hola, astaghfirullah. Okay, I'm being normal. I'm being professional. Right. Sine x plus 15. I can't. I just can't do it. I can't do this anymore. I need my meds. Right, x plus 15. So now your reference angle is 63,43. So quadrant 1, you must give 2 solutions. Hey, bro. So your first solution is going to be x plus 15 is equal to, wallah, these guys are going to think I'm mal. Qasam. I'm worse than what you think. I promise you, I'm on my best behavior. You ain't seen nothing yet. So 63,43 plus k, that's quadrant 1. 3 times 360, where k is an element of integers. Whenever I go with my wife, she tells me, I can't take you nowhere. Please just shut your mouth. Please keep your mouth closed. You're going to get us into trouble. Everywhere you go, you're going to get us into. So 63,43 minus 15. So 63,43 minus 15. You know what's it like being with a person where you're on your toes all the time? You don't know what the hell the O is going to do. That's me, bro. 48,43 plus k times 360, where k is an element of integers. Sorry, SA. Sorry. Okay. Sorry, not sorry. Q2, quadrant 2, x plus 15 is equal to 180 minus 63,43 plus k times 360, where k is an element of integers, so x is equal to 180 minus 63,43 is equal to 116,57 minus 15. And that will give you 101,57, 101,57 plus k times 360, where k is an element of integers. And there we go. Hassanin, you mustn't act like an angel. I think you're worse than me. You're just trying to put on a face there. You're trying to be civil to keep your job. I think you're worse than me. I think if the two of us have to sit together, I'm going to hear lots more coming out of your mouth than mine.
So why don't we go on a fishing trip?
I'm telling you, needs to be done. And you know where? There's a place in Cape Town. I'll never forget. It's called Tweede Tol.
Okay, I know that place.
You know that place? Ah, amazing.
Yeah.
We did cliff jumping from there into freshwater ponds. Amazing. Amazing. I'm not advertising for SA National Parks, right? They need to pay me. So I'm not going to tell you all where it is. They need to pay me.
Okay, moving on,
Shayataf.
Mr. K.
I'm getting censored here. Okay, anyway, there we go. I'm seeing red flags coming up here. If it was my own show, I'd just say, check. Right, let's go. Okay, Astaghfirullah. Let's go. So we're done with that one there. Let's now do another one. Now watch this one. Now we're going to have one that will, let's say, 3 cos 2x minus sin 2x minus 2 equals 0. Give the general solution, bro. And that's worth 6 marks. Answer. Ish, give the answer. 3 cos 2x. I just forgot the S. The pen is moving. The mouth is moving faster than the pen. 3 cos 2x minus sine 2x minus 2. Now, whenever you see a cos 2x and a sine 2x, you know you've got to break it up, right? Do you guys want to give it a go on your own? Or you want me to do it for you? I'm not going to be with you in your exam, right? Okay, you want me to do it for you, right? You're looking at me with that blank puppy dog look. So 3 cos 2x, use cos squared x minus sine squared x. Minus sine 2x is 2 sine x cos x. Minus 2 equals 0. So let's break this up. What do we get? 3 cos squared x minus 3 sine squared x. Hassanin, if I eat Pringles, will you be able to hear the crunch?
Yes, I will.
Oh, shucks.
Because
So I
the
can't
audio pickup is quite sharp on there. So what you
Oh,
can
okay.
do is you can
You'll
take
be able to
perhaps
hear me
a
crunch, and then you'll be able to hear the Pringles go down my throat and my stomach get. Okay, moving on along. Okay, minus 2. Now look here, guys. What we want to do is we want to bring in. We got a sine x cos x. We want to make it a quadratic equation. Now, in order to make it a quadratic equation, what we want to do is we want to bring in a sine squared and a cos squared, because that won't be a quadratic. So what we do is we just attach sine squared x plus cos squared x at the end is equal to 0. Because sine squared plus cos squared is 1. So we're not changing the original. We're just introducing sine squared and cos squared. So now we got 3 cos squared x minus 3 sine squared x minus 2 sine x cos x. Hey, how's the fellas from Tongat and all? Hey, machine, exe. What a program and all, eh? Machine, Mr. K.
We don't
Dalai.
talk like that. We don't talk like that, Mr. K.
Wait, Tongat. Hey, Tongat Phoenix. Hey, what kind, Bali?
We're speaking
Minus 2
proper
cos squared x.
English.
This is South Africa. We are diverse. Diversity. 3 cos squared x minus 2 cos squared x is 1 cos squared x. You can hear me clearly, ne?
Loud and clear.
Okay. Then we've got minus 2. Minus 3. So let's put our minus 2 sine x cos x in the middle. Minus 3 minus 2 is minus 5 sine squared x is equal to 0. Right, so 3 cos squared x minus 3. Yeah, that works out. Okay, what happened here? Maybe it's supposed to have been plus 2. If it was plus 2, then 3 plus 2 would have been 5. Look here, this one here doesn't factorize perfectly because now I got my factors of 5. What are my factors of 5 to give me a 2? So this one here won't factorize. But look, what you would normally do, because I made this one up, so it doesn't factorize perfectly. So you'll break it up into your 2 factors. You'll make each factor equal to 0, and then you'll give your general solution. So say, for example, you had, let's say your first bracket was 2 cos x plus sine x, right? Just say, for example. So then you're going to say 2 cos x plus sine x equals 0. So now what we want to do is we want to now make this, or you're going to have your second solution, right? This one here won't work out. But in your exam, you'll get a perfect trinomial. So just make sure in your exam at that point there, you're going to get a perfect trinomial. So now you're going to get sine x is equal to minus 2 cos x. And then you're going to divide by cos, and you're going to divide by cos. You're going to get sine x over cos x is equal to minus 2. So sine over cos. So your first solution, you're going to get tan x is equal to minus 2. So x is equal to shift tan 2, shift tan minus 2. You're going to get minus 63,43, minus 63,43 plus k times 180, where k is an element of integers. That's your first solution, and then you'll do your second solution here. Do you understand what I did? You guys all good? You know what we did. So what you do is you break it up, you make it a quadratic equation, and then you factorize it. So we're going to do a couple of examples, so don't worry about this one too much. In fact, don't worry about it, learn it. Our online guys are okay, Hassanin? Everybody's all okay, everybody's logged on.
Yes, they diligently penning away, working out the solution to this problem over here.
I'm going to give you another one from a past paper, guys. After this, also a general solution. I'm going to show you the different variations in which general solution can be asked. I can't do all, guys. I'd love to do all. If you guys want to see much more, again, like I said, join us next weekend. Next weekend's also going to be a bumper weekend. Paper 1 on Saturday, paper 2 on Sunday. Okay, so I'm clearing the frame. Let's try this one. Let's see if you guys can do this one. So they say give the general solution. Come on. Right, they want the general solution of tan x equal to sine 2x. Basically, you're finding all the points of intersection where these two graphs will meet. That's what you're basically doing. So find the general solution, show all calculations for 6 marks. Let's see, how would you guys do this? Kuvadia? Umaid? Zaim? No, it's not an identity. It's not left-hand side, right-hand side. You're working with both sides here. That's your double angle for sine, and the tan you're going to... Okay, so watch here what we do in our answer, right? So in our answer, we're going to say sine x over cos x. Hamza, you're following. Yasin, you're following. And then sine 2x is 2 sine x cos x. Right. And that's over 1. So what you can do is now cross multiply. Agreed? So now you're going to get 2 sine x. Cos times cos is cos squared x is equal to 1 times sine x is sine x. Now I'm going to take this. Do not divide by sine and divide by sine. You cannot get rid of it. So what you're going to do is you're going to do 2 sine x cos squared x minus sine x is equal to 0. Now you're going to pull out your highest common factor of sine x. And then you're going to get 2 cos squared x minus 1 equal to 0. That's your HCF. Now we got 2 factors equal to 0. So you got sine x equal to 0, or you got 2 cos squared x minus 1 equal to 0. So now you're going to have x is equal to shift sine 0 is 0 degrees plus k times 360, where k is an element of integers, or x is equal to 180 plus k times 360, where k is an element of integers. And on the other side, you're going to have cos squared x is equal to cos squared x. Take the 1 on the other side, divide by 2, you're going to get a half, right? So cos x is equal to 1 over root 2. I'm just writing it here, 1 over root 2. That's your special angle. So x is equal to plus minus 45 plus k times 360, where k is an element of integers. They don't give you a restriction. You just put it. Yes. No. Yeah, if you wanted to, you could. Ah, that was smart. Oh, you saw that. Okay, no problem. I'm sure if you did that, let's just see. If we made 2 cos squared x minus 1, I'm glad you picked that up. So it's cos 2x is equal to 0. Right? So shift cos 0. Shift cos 0. You get 90. Yeah, that also works. So that means 2x is equal to shift cos 0 is plus minus 90 plus k times 360, where k is an element of integers. So x will equal to plus minus 45 plus k times 180, where k is an element of integers. Hey, good shot. If you saw it like that, very good. No problem. No problem. The answer to this here gives you this one here. But if you did that in your exam, you'll be a boss. You'll show your examiner, you the O. Right, I'm going to try and I'm going to give you guys, while you're taking this one down, and if you guys feel that you're writing a little too slow or whatever, take a screenshot of it. You got your phones, use technology. You are all tech geeks. We are all the millennials. Take your phones, take a screenshot. You can always take it down later. Otherwise, go to www.awqafsa.co.org.za and just go there and review the whole program. Right.
Thank you for butchering our web address there. But
www.awqafsa.org.za. I got it. I didn't butcher.
11 out of 10 for you, Mr. Kai, for effort there. We appreciate that.
Shukran.
You're improving. There's some improvement.
Ufa, me bro.
Oh my
Yeah.
word.
I know that the Capetonians there from Mitchell's Plain must be saying, yo, hiripang, dipang. Is mos niks lekker. Ja, pang, kompang. Okay, I'm taking this thing. Let's take it away. I'm clearing the frame. Now, what happens if you had a situation like this? Come on, mister. Clear the damn frame. You're not supposed to use the word damn. So, what if they told you sine x minus 45 is equal to cos 2x? Give the general solution for 6 marks. That's cos 2x. Let me write that better for you. Chuk, 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 chuk. Cos 2x. Come, try it, guys. Try it, guys. Give it a go. Let's see how prepared are you for your exam. Now imagine, Hassanin, you can't control me on a platform. Imagine my teachers in school. I feel I'm sorry. No, I'm not from Mitchell's Plain, Dale, Yankees, but I know Mitchell's Plain in and out. I know Spine Road, my bro. I know Spine Road. I know Cedar
Mr. Kota,
High.
Mr.
Yes.
Kota,
Yeah,
what were
Baba.
you like in classroom? Were you a
Yeah,
problem child? Were you a juvenile
astaghfirullah. Don't.
delinquent?
I'm telling you, it was bad. It was bad. It was bad. I was kicked out of Matric. My whole Matric year, I was kicked out of class. I had to learn math. I had to learn school from outside the class window with my hands on the window, looking at everybody in the class. I was kicked out of class every day.
Oh, okay. So I
It was
think
bad.
that's your claim to fame and perhaps part of your charm, right?
The only thing, Hassanin, the only thing I remember from Matric was sitting outside on school. You know those black dustbins? I even
Yes.
remember, you know the ones that it says, here, no hot ash, geen warm as. That's the only thing I could read on the sitting on the lid of those black dustbins. Serious.
Okay, but you came out for the better. You're of some value to society and so on. So you're adding
I'm
value
hoping.
today.
I'm
Yeah,
hoping.
yeah.
Inshallah. 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 Well, I got 100% in grade 12, brah.
Hmm. You're very unorthodox, Mr. K. But I think there
Total
is some
rebel.
method.
Total rebel. Total rebel
Yes.
to society. I scare myself sometimes. Okay, in any case, back to math, bro. Allah must forgive me. Astaghfirullah. Okay, right. Here we go. Sine x minus 45 is equal to cos 2x. So what you want to do, guys, hey guys, what you want to do is sine x plus 45. You want to convert this to a sine. So you're going to make sine 90 minus 2x. Right, because sine 90 will change it to cos 2x. And what you want to do now is you want to cancel. The minute you cancel, you split it up. So you get x minus 45 is equal to 90 minus 2x plus k times 360, where k is an element of integers. I'm every teacher's nightmare, honestly. Or x minus 45 is equal to 180 minus 90 minus 2x plus k times 360, where k is an element of integers. Right, so now we solve for x. So x plus 2x, 3x is equal to 90 plus 45 is 135, ne? 135 plus k times 360, where k is an element of integers. So x will equal to 135 divided by 3 is 45 degrees plus k times 120, where k is an element of integers. And on this side, we had x minus 45 is equal to 180 minus 90 plus 2x plus k times 360, where k is an element of integers. So then x minus 2x is minus x is equal to 180 minus 90 is 90 plus 45 is 135 plus k times 360. Are you guys all following? I'm sure you're all following. Take these templates down, learn them, memorize them. Minus k times, because you're dividing by minus 360, where k is an element of integers. Now here it's 120 because we divided by 3, we divide by 3, we divide your general solution also by 3. Agreed? And these are, that's your 6 marks. So you'll get 3 marks there and you'll get 3 marks there. Take that down, take that down, take that down. I'm gonna leave you guys with one general solution. You know what? We should have a little bit of a competition here. The first person to get it right will get like $50.
Are you gonna
Isn't it?
e-wallet that? E-wallet
Yeah,
that
we'll
to
e-wallet it to them. Let's see how sharp they are. The first person, Hasanain, put your cell phone number, the first person, and you guys got to take a photo of it and then send it via WhatsApp. Okay, let's give them, I'll even give them $100. I'll give it to them. Okay, do it to me. Send it to my WhatsApp. 081 7063986 to the next one. You get it right, you get $100. We e-wallet you after the show.
Mr.
Are you
Kaushal, we
ready?
have a question from Ashika. She mentioned something about co-ratio.
Yeah, co-ratio. Yeah. No, she's
Yes.
making a statement. Yes, it's the co-ratio.
And we've got another question. Can we change the sign
No,
into
try
cos?
not to. No, do the cos to sign. Do the cos to sign. Mpumza, it's okay to change the sign into cos, but you might pick up a little bit of difficulties. Rather do it the other way. Do the cos to sign. Don't do the sign to cos. Do the cos to sign and then give your two, break it up and give your two general solutions. All right. Are you guys ready for the next one? $100. But you got to take a photo of it and send it to my WhatsApp. Right, let me clear the frame.
Or can't they